Hi, and welcome to this section of the tutor where we're going to talk about a very important section in math, and that's called fractions, okay? Fractions can sometimes seem difficult because they don't look exactly like real numbers, okay? And they can seem to be a little bit challenging at first, but I promise you if you stick with me, I'll teach you what a fraction is. And in this section, we're going to learn what a fraction is, and we're also going to learn how to, what we call simplify fractions, and that'll all make sense at the end of this section. And then we'll go in later on and we'll learn how to add them and subtract them and all that good stuff, okay? But first, let's talk about what is a fraction. It's a very important topic, so let's go in and talk about that right away. I'm going to use pi as an example all the time in this class, okay? So I hope you guys like pi because we're going to talk a lot about pi's right now. I think everybody knows what 3 pi's would look like, right? You'd have 1 pi, 2 pi, 3 pi. These are circles, and each one of these is a pi, okay? So I think you can visualize in your head what 3 pi's would look like. So just hold that in your head for a second, okay? I think you could also visualize what 2 pi's looks like in your head. That would be 2 giant pi's, right? I love pi myself, and having 2 pi's is even better than having 1 pi. I think you also would know what 1 pi looks like, which would just be 1 circle, okay? But the question is, 3 pi's, 2 pi's, 1 pi, what happens when you start cutting the pie up, okay? What do you call those pieces of the pie? Because if the pie is one whole giant circle, we call that a pie, and you start cutting into that pie, well, if you start eating some of the pie, then what you have left over isn't going to be a whole pie, right? It's going to be something less than a pie. It's going to be a part of the pie, but it's not going to be a whole pie. And what we're going to say is that you're going to have something left over, you know, when you cut out there, and you're going to have some pieces left over. And what we're going to do is we're going to talk about fractions. You have a fraction of the pie left. You have something less than 1, okay? So basically, anytime you have something less than 1, you can talk about it in terms of a fraction, because that's what it is. A fraction is used to talk about things when you're talking about less than 1 of them, okay? So 3 pi's, 2 pi's, 1 pi, we're going to start cutting the pies up, and then we're going to have less than 1 pi, and we're going to have a fraction. So let's say we have, this is our whole pie here, okay? This is our whole pie. Actually, let me go ahead and erase this real quick. I'll make it clearer. Here's our whole pie right here. We said this was 1 pi, okay? Now, let's say for some reason I cut this pie down the middle, like this, okay? And I take this half over here, and I give it to my dog, okay? So my dog eats it. He loves pie, okay? Well, I have some pie left, right? How much pie do I have? I think you can probably realize, or most of you have heard the term half of something. If I take this pencil and I break it in half, then I cut it right in the middle, right? Well, I've taken this pie and I've cut it down the middle, and so we've taken away half of the pie. And what we have left, we have half of a pie left. Now, how do you write that down? Well, you can say that this is half of a pie, okay? Half of a pie, and that's absolutely true. But in math, you want to write this stuff down in terms of a number, right? So you can also write it down like this. Once I first cut the pie, I had 2 pieces, right? So I'm going to say I had 2 pieces here. But when I take 1 pie and I throw it to my dog, how many pieces do I have left? I only have 1 piece. So this is called 1/2, okay? I just take a 1, which is how many pieces I'm talking about, okay? Or if, in this case, how many pieces I'm talking about here, okay? Out of 2 possible pieces, okay? And this is what I have. And you just draw this line in the middle, and this just means it's a fraction. It's just telling you that you have less than 1, okay? So I don't have a whole pie. I have half of a pie. The top number tells you how many pieces that you have, and the bottom number tells you how many total pieces you have. So this is how you can talk about things less than 1. I take this, I throw it away, okay? So how many do I have left? Well, I have 1 piece out of a possible 2 pieces. So I don't have both pieces. That would be a whole pie. I don't have both pieces. That would be a whole pie. I threw 1 piece away. I have 1 piece left out of a possible 2 pieces. So I have half a pie. This is called 1/2, okay? Now, what would happen if I took the pie, okay, And what if I cut it up like this? What if I cut it down like this and then across like this? Okay? And let's say I'm going to eat some of this pie. I like pie, okay? So let's say I take this piece here and I just take this piece out of the pie tray and I eat it. And that's the only piece that I eat. How much pie have I eaten? That's my question, okay? Well, this is called a quarter of a pie. So this is quarter of a pie. And you might have even heard about that before. You may have heard that word, a quarter of this, a quarter of that. But in math, how would you write it? I've got one piece in my mouth out of a possible total of 4 pieces. So there's 4 pieces available because I cut it to make 4 pieces, right? But I'm only eating one piece. So the piece that I took is 1/4 or 1/4. It's the same thing, okay? So this is how you write it. You're talking about fractions here. That's exactly what this is. These are both a fraction. This is a fraction, this is a fraction. Now, obviously, this is more pie than this, right? So this fraction, 1/2, is more than 1/4. Now, it's not so easy to see that here by looking at the numbers, but by looking at the pictures, this is a whole lot more pie than this, okay? All right. Now, what I want to show you next is, what if I look at this half a pie in a little bit different way, okay? We just talked about what a half is, and we just talked about what a quarter is, okay? What if I took this pie, okay, here's my pie, and I cut it right down the middle in half, okay? And I'm going to use blue here because I like blue. And I take this half away, okay? How much have I taken away, okay? This is 1/2 of a pie because I've taken one piece away out of a possible 2 pieces. That's 1/2 of the pie, okay? Now, hold that in your brain. We're going to talk about this for a second. What if I have another pie and I cut it again just like in the previous board like this, okay? But I don't just take one piece of this pie away. I take 2 pieces away. So I'm going to take all of this. I'm going to take 2 pieces of pie and I've cut it into 4 pieces. So how much have I taken away here, okay? Here, okay, there was 4 pieces, okay, and I took 2 of them. So I took 2 pieces, 1, 2, out of 1, 2, 3, 4 total pieces, okay? That is a fraction. So anytime you write a fraction down, the top number is how many pieces do you have, and the bottom number is how many total pieces are there, period, okay? So you have 2/4 here, okay? Now what I want to show you, and this is very, 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 very important, okay, is that this looks different than this, okay? These 2 fractions look different because I've written them down. This has a 2, this has a 1, this has a 4, this has a 2. They look different. But look at the pictures for a second, okay? Even though I've taken 2 pieces out of 4 over here, and even though I've taken 1 piece out of 2 over here, the total amount of pie that I eat in each case is the same. So in other words, these 2 fractions, even though they look different, are the same thing. They're no different from one another. They are exactly the same thing. I cut the pie in 2 pieces, I eat half the pie. If I cut this pie into 4 pieces and then take 2 away, I've eaten the same amount of pie. It is exactly the same thing. They only look to be different, okay? They only look to be different. So, these 2 things must be equal. They must be equal, and they are equal. They're exactly equal, okay? 1/2 is equal to 2/4, 2/4. It must be this way, okay? Why is it this way, okay? Well, I'm going to go ahead and show you that 1/2 is equal to 2/4, exactly equal to. Why is that? Because what you can do is you can take this fraction and you can do what we call simplify it. Fractions are cool because they're kind of like a seesaw. You see, on a seesaw, you put one person on one side, you put one person on the other side, okay? And if you're going to balance that seesaw that's over here, you're going to balance that seesaw, right? So if you put some bricks on one side, if you're going to keep it balanced, you're going to have to put some bricks on the other side. So in order to keep the seesaw balanced, you can do the same thing to each side of the seesaw. Add some over here, add some over here. add some more, add some more. You can do the same thing to each side of the seesaw and it stays balanced, okay? A fraction is the same way. I can do whatever I want to the top and I can do whatever I want to the bottom. As long as I do it to both, then I have the same fraction, okay? So tell me, if I start out with a 2 on the top and a 4 on the bottom, okay, what happens if I divide the top by 2? And what happens if I divide the bottom also by 2? I've done the same thing to the top and the same thing on the bottom, okay? What is 2 divided by 2? Well, that's 1, because anything divided by itself is 1. What is 4 divided by 2? Well, that's simply 2, okay? So notice what we've done. I've taken the 2/4, I've done the same thing to the top and the bottom, and I have arrived at a different fraction. And look at this, it's the same fraction as this one. So we've arrived at 1/2. So what I'm trying to tell you is, we started with 2/4, and that looked like it was a totally different fraction. The picture seems to make it seem like they're the same, but what we proved, though, is that by dividing the top by 2 and dividing the bottom by 2, we got the same fraction. We have simplified that fraction. We have reduced that fraction into its lowest terms, okay? There's nothing else you can divide the top and the bottom to make that any simpler, okay? You just, anytime you have a fraction, and you're gonna have problems like this where you have to simplify fractions, go ahead and see if you can divide the top and the bottom by the same number, and then you can simplify it as far down as you can go. And you can go from there. So let's go ahead and do some more problems. And let's go ahead and draw some more fractions and continue to introduce fractions, and let's simplify those fractions. And I think you'll see that it's not that hard, okay? It's not that hard. What if you have, okay, what if you have a problem like this? Here's my pi, and I'm going to draw this, and I'm going to ask you what the fraction is, okay? Here's my pi, and I'm only going to take this much of it. Question is, what is the fraction represented by this? Okay, first thing you have to ask is, how many pieces do you have, and how many total pieces are there? Okay, you have one piece, so the 1 goes on the top, okay, and the bottom number is, how many pieces do you have? 1, 2, 3, 4, 5, 6 total pieces, so it's 6. So this is a fraction called 1/6, okay? It's just a fraction. It's just telling you that you don't have a whole pie, you have 1/6 of a pie, one piece out of 6 pieces. So you don't have a whole pie, you just have a piece of a pie, okay? So let's do it again. Let's do it again. Okay, I'm going to do the same thing here. I'm going to draw it like this, and I'm going to cut this pie up into 6 pieces, okay? And then, I'm not going to take one piece, I'm going to take 2 pieces. So here we go. Here's one piece of the pie I took, here's another piece of the pie I took. Okay, what fraction are we dealing with here? Again, the first thing you do is, how many pieces do I have? That's 2 pieces. And how many total pieces are there? 1, 2, 3, 4, 5, 6 pieces. 2/6, okay? Okay, now, 2/6, okay? Now, the question is, this is correct, this is the fraction, but anytime you have a fraction, you're going to need to always check, and your problems are going to ask you to reduce the fraction into lowest terms, okay? So the question is, can you do anything to the top of this fraction and the bottom of this fraction to make it any simpler? Can you divide the top by a number and the bottom by the same number and do that successfully to the top and the bottom and make this fraction any simpler? And I say that you can, because if you take the top and divide it by 2, and you take the bottom and you also divide it by 2, you will get 2 divided by 2 is 1. The bottom is 6 divided by 2, and that is 3, because 3 times 2 is 6, okay? So this is what we call simplest form, simplest terms. It's reduced, okay? Because you can't divide the top by anything and the bottom by anything else and make this fraction any simpler. You can't do that, because you've got a 1 and a 3. You just can't do anything more. What this tells you is that the fraction 2/6 is exactly the same as the fraction 1/3. They are exactly the same. There's no difference. They just look a little bit different. It's written a little bit differently, but the fraction is the same. It's kind of like if I give you a dollar bill, okay? That's $1. And I give you 4 quarters, okay? That's $1, okay? You've got the dollar. You can only buy so many candy bars with it, but one of them is 4 quarters and one of them is a piece of paper, the dollar bill. But they're the same thing. Same thing here. 2/6 is the same as 1/3. Now, in order to prove ourselves of that, let's figure out what that would look like if we were to draw it. Here's a pie, and I want to divide that pie up into 3 equal pieces. 3 equal pieces, okay? 3 equal pieces. And from these 3 pieces, I'm going to take 1 piece off the top, okay? So what fraction would this be? Well, I've got 1 piece out of 3 equal pieces. So this is what we call the fraction 1/3. Notice that it looks exactly the same as this over here. I'm showing you by drawing that 1/3 is exactly the same thing as 2/6, even though they look a little bit different when you write the numbers down. This is why you can reduce it and it is the same thing. Here you have 2 pieces out of 6, here you have 1 piece out of 3, but the same amount of pie goes into your tummy in each case, okay? All right, good. We're going to go ahead and continue working more of these fractions and simplifying fractions. And we're going to get the hang of it by working through a lot of problems, okay? So, what if I had a fraction, or a pie, I should say, that looks something like this? I'm going to divide it up into 6 pieces, like I usually do, okay? But in this case, I'm going to take 1 piece here, another piece here, and another piece here, okay? 3 pieces. Okay. What fraction would this be? I've got 1, 2, 3 pieces out of a total possible of 1, 2, 3, 4, 5, 6 pieces. 6 pieces. Okay? Question you always have to ask yourself, even though this is correct, this is exactly right, can you reduce this fraction? Okay? Can you reduce this fraction? I say you can, because on the top you can divide by 3, and the bottom you can divide by 3, and they'll both divide evenly. 3 divided by 3 is 1, okay, on the top. 6 divided by 3 is 2 on the bottom. So, what we're claiming here is 3/6 is the same thing as 1/2, because we can divide top and bottom by the same thing, and we'll get something a whole lot simpler, and we can't do anything more to this. We can't simplify that anymore. Well, let's go ahead and check and see if this makes sense. If I look at 1/2, I would say, well, let me divide this pie into 2 pieces, 2 pieces total, and I'm going to eat 1 of those 2 pieces. Now you can see this amount of pie is exactly the same as this amount of pie. Even though it looks a little different, 3/6, it looks a little different than 1/2. It's the same amount of pie in each case, and that's because I can reduce this fraction. So you're going to have a lot of problems that are going to tell you, make this fraction lowest terms, reduce this fraction, that kind of stuff, okay? And it's not terribly difficult. You're just going to have to take it slowly. Let's take another example. Let's say you have a pie. I'm going to divide it into 8 pieces, like this. And I'm going to take away, because I'm kind of hungry, 1 piece. How would you write that fraction? Okay. Well, I've got 1 piece of pie out of a possible of 1, 2, 3, 4, 5, 6, 7, 8 pieces of pie. So this is the fraction. It's called 1/8. Can you reduce this fraction anymore? No, you can't, because you can't divide the top and the bottom by anything different or anything else and make it any simpler, because the only thing divides into 1 is 1. So you really can't do that. But let's look separately over here, and let's say, what would this be? I'm going to divide this fraction, I'm going to divide this pie again into 8 pieces, okay? And I'm going to take 2 of those pieces. Here's a piece for me, and here's a piece for my friend. Taking 2 pieces. What fraction of the pie do I have in this case? I've got 2 pieces, okay, out of a total possible 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8 pieces, like this, okay? 2 over 8, okay? Now, can I reduce this fraction? I say yes, you can, because you can divide the top by 2 and you can divide the bottom by 2. This is where multiplication and division become very, very important, because I know that 2 divided by 2 is just going to give me 1, and 8 divided by 2 is going to give me 4. So I can reduce this fraction by dividing the top and the bottom by the same number, and I get 1/4. So what we're saying here is that the fraction 2/8 is exactly the same as the fraction 1/4. Let's see if that's true. Let's draw another pie over here, and let's divide it into 4 pieces. And let's go ahead and take this and see if it makes sense. Okay? Here is my piece of the pie that I take right here. Okay? 1 piece out of 4. Now you can see, even though this is kind of rotated, that this pie, this total amount of pie, is equal to this total amount of pie right here. So they are indeed exactly equal to one another. Okay? So this fraction over here is going to be 1/4. So what I'm showing you by drawing is that 1/4 is equal to 2/8. Okay? So what we're showing here is, and you're not going to be drawing these pies on your test, but I'm showing you by drawing that you can take a fraction and you can reduce it and you get the same representation of the pie, but it just looks a little bit different. Okay? We're going to do one more of these examples with the drawing business, and then we're going to kind of simplify some fractions without drawing them. Okay? So let's say you have, again, I'm going to draw this pie and I'm going to make 8 pieces. Okay, there's 4, 5, 6 pieces, 7, 8 pieces of pie, and I'm going to take 3 of those pieces. So here's 1 piece, 2 pieces, 3 pieces of the pie. Okay, 3 pieces of the pie. So 1, 2, 3 pieces of pie out of a total of 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8 pieces. Okay. All right. Now, let's go ahead and here and see what something a little bit different looks like. Let's see, I have 8 pieces of pie again, and let's go ahead and take 4 pieces. Now notice in this case I couldn't simplify it anymore because I can't divide the top and the bottom by the same number that's going to make this any simpler. I can't divide by 2 here because it won't go into 3 an even number of times. I can't divide by 3 because if I divide by 3 on the top, well, 8 divided by 3, it doesn't give you an even number either. So you really can't simplify that one anymore. But let's go over here and let's take 1 piece, 2 piece, 3 piece, 4 piece, and let's see what happens. This fraction is going to be 1, 2, 3, 4 pieces out of a total of 8. Again, it's the same 8 pieces. Okay? Can you simplify this fraction? Yes, you can, because you can divide the top by 4, and you can divide the bottom, again, by 4. Okay? And when you do that, you'll see that 4 divided by 4 gives you 1, and 8 divided by 4 gives you 2. So what we're saying here is that 4/8 is exactly the same thing as 1/2, and it's because it is this way because I can divide the top and the bottom by the same number, and as long as I do the same thing at the top and the bottom, I'm okay. Now let's draw this and see if that's true. I take my pie, divide it into 2 pieces, and I take 1 piece home. That's this piece here. This is 1/2 of the pie. This is 1/2 of the pie. Even though 4/8 looked a little bit different, it is indeed the same. Okay, now what we're going to do is we're going to practice simplifying fractions because that's going to be a big part of your homework. And then, but we're not going to draw pictures here. We're just going to simplify the fractions. So the question is simplify the following fractions. 5/10. Can you simplify that? Yes, you can, because you can divide the top by 5 and you can divide the bottom by 5. Okay? So on the top, what you're going to have is 5 divided by 5 is 1. The bottom, 10 divided by 5, is going to give you 2. And you can't do anything more with that because that's fully simplified. You can't divide the top and the bottom by the same thing and get anything simpler. 5/10 is equal to 1/2. Now let's say you have 8/16. Can you simplify this? And I say yes, you can, because you can divide the top by 8 and the bottom also by 8. Okay? And when you do that, 8 divided by 8 is going to give you 1. 16 divided by 8 is going to give you 2 because 8 times 2 gives you 16. Okay? Now let's try another problem. Let's say you have 2/4. Can you simplify this? And I say yes, you can, because you can divide the top by 2 and the bottom also by 2. Okay? And when you do that, the top is going to be 2 divided by 2 is going to give you 1. the bottom is going to be 4 divided by 2 is going to give you 2. Now I picked these 3 examples on purpose because they all reduce to 1/2. What I'm saying here is that this fraction looks different than this fraction, looks different than this fraction, but they're all the same thing. And if you were to draw the pies here, you would see that if you draw 5 out of 10, 8 out of 16, 2 out of 4, when you shade it all, it's going to all look like half the pie, okay? So you need to be real careful in fractions to make sure that they're simplified so that you really understand what it means, so you can go ahead and add, subtract, and all that stuff that we're going to learn about later. Now let's say you had, getting into this a little bit more, just simplifying, let's say you have 3 divided by 15. This is 3/15ths, 3 pieces out of 15 possible pieces. Okay, how would you simplify this? Well, you can simplify this because you can divide the top by 3 and the bottom by 3. And when you do that, 3 divided by 3 is 1. 15 divided by 3 is 5. Because 3 times 5 is 15. So 3/15ths is equal to 1/5. Okay? Let's take 5/15ths. It's very similar. Can you do that? Well, you can divide the top by 5 and the bottom also by 5, and those will both divide evenly with no remainder, which is what you're trying to do. 5 divided by 5 gives you 1. 15 divided by 5 gives you 3. So that reduces to 1/3. So if you were to draw 5/15ths and 1/3, they would look the same. Okay? What if you had 10/15ths? Okay? How would you do that? Well, you're trying to find a number that you can divide the top and the bottom evenly. So I'm going to pick 5 because I know 5 goes into 10 and I know 5 goes into 15. Okay? So 10 divided by 5 gives me 2. 15 divided by 5 gives me 3. And I can't reduce that anymore. So that is all simplified. Okay? 10/15ths is equal to 2/3. Okay? Let's do a couple more here. Getting a little bit bigger numbers here. What if you had 18 divided by 36? 18/36. That's a fraction, 18 over 36. Well, let's go ahead and, I'm not sure what the proper answer is, but I know that 9 goes into 18. So let me go ahead and do by 9. I also know that 9 goes into 36. Okay, so let's go ahead and see where that leaves us. 18 divided by 9 gives me 2, because 9 times 2 is 18. Okay, 36 divided by 9 is going to give me 4, because 9 times 4 is 36. Okay, now I'm left with a fraction that I can further simplify, okay, because I can divide the top again by 2 and the bottom again by 2. And that is going to give me 1/2, because 2 divided by 2 gives me 1, 4 divided by 2 gives me 2. So notice that you just pick the first number you can that's going to divide evenly, and then if you're left with something else that you can further work with, do it again. Pick a different number, and then you'll eventually arrive at something that you can't simplify anymore. Finally, what if I had 25 over 100, 25 1/100ths? Well, what can I divide here? I just happen to know that I can divide by 25, and I can divide by 25. And so 25 divided by 25 is 1. 100 divided by 25, I know, just goes 4 times. So that's equal to 1/4. So fraction is basically a part of a whole. It is a representation of something when you have less than 1, less than a whole pie, less than 1 of something. And just because the fractions might look different doesn't mean that they may not be equal, so you have to do this thing called simplification, which is just taking a look at the top and the bottom and dividing the same number into each till you get to something that you can't simplify anymore. Practice this. Practice is very important. Fractions are used everywhere. Practice, and I promise you that you'll get the hang of it. Hi, and welcome to this section of the tutor where we're going to continue our work with fractions. This far we've learned about what fractions are, we've learned how to simplify fractions, and I've kind of spent a little bit of time teaching you what a fraction is, okay? And don't forget that fractions are just another kind of number. We talked about that before. Fractions are just numbers when you have something less than 1, half of a pie, quarter of a pie, something like that. And because they're numbers, you can add them, you can subtract them, multiply, divide them, and that kind of thing. And so in this section, we're going to learn how to add and subtract fractions. And we're going to do it when you have a common denominator. And I'm going to teach you what a common denominator is here in just a minute. But just don't forget the big picture of what we're doing here. Fractions are just a certain kind of number when you're talking about things less than 1, and we're just going to add them, and I'm going to teach you the rules on how to do that now. So let's go ahead and talk about adding and subtracting fractions. Okay? Remember back from the previous section, okay, here's a pi. It's my favorite thing in the world, pi, okay? And we've already talked about the fact that this would be 1/2 of a pi, okay? You already know this, 1/2 of a pi, okay? So you write it like this, 1 piece out of 2 possible pieces. So I've only got half the pie, okay? Now let's say over here on another table, I have a separate pie, fresh out of the oven, okay? Now I'm going to also divide that into 2 pieces, and I'm going to have this piece here I'm going to be talking about, okay? So here I have half of a pie, here I have another half of a pie. Nothing new so far, this is just half of a pie, here's another half of a pie, okay? Now what happens if I try to add these 2 things together, okay? You can kind of think about it for a minute here. Here's half of a pie, okay? You cut it in half, you got half of a pie. And the other half is in the trash can or something like this. And then you have a totally separate pie you've cut in, your grandma cut it in half for you and threw the other half in the backyard. So I have half of a pie here and a half of a pie here. If I put them together, just forgetting about the math involved, what do you think you're going to have? Well, you're going to have 1 whole pie, right? Because here's half of a pie, here's another half of a pie. If you put them together, you can see that you could kind of put this inside here and you would have 1 whole pie. So if you did that, then if you could, kind of like a puzzle, take this piece out and kind of flip it over and put it over here, then what you would have is 1 whole pie, okay? Like this, okay? So what we've done is we've taken a fraction and we've added it to another fraction and we've ended up with a number here, okay? Now, how can this be? I mean, it makes sense just by looking at the pictures, but how does this added with this equal 1? And that's what I'm going to teach you here, okay? Let's go ahead and write it down. 1/2 plus 1/2, okay? Now, briefly, I want to go ahead and tell you, the number on the top, you already know what it means. It's the number of pieces you have. And the number on the bottom, you also know what it means. It's the total number of pieces in the pie, okay? But this top number has a special name, and it's called a numerator. And this bottom number has a special name, and it's called the denominator, okay? Numerators on the top, denominators on the bottom. You can kind of think of denominators, it just kind of sounds like low. Denominator is kind of down low, okay? Low denominator, okay? So it's down here on the bottom. Just think of it that way. And numerators on the top. The one rule of adding and subtracting fractions that you're going to have to learn, and it's not hard, is this. In order to add any 2 fractions together, the denominator of the fractions must be the same. They must be equal. So here the denominator is 2, here the denominator is 2, because here I have my fraction set up where I've got 2 pieces here and 2 pieces here, a total number of 2 pieces in each pie. So 2 and 2. Because that is the same number, I can add these fractions together. If I had a different number in the bottom, then I'd have to do a little bit of work in order to add them, and we're going to cover that in the next section. So for now, because this is a 2 and because this is the same number, we can add these right away. So the question is, how do you add fractions? Well, it's very, very easy. You just put your line, because in the end you're going to have a fraction. Now on the bottom, you just keep the same number. So you don't actually add these 2. If this was a 3 and this was a 3, then you would put a 3 here. If this was a 79 and this was a 79, you would just put 79 here. So it's real easy. The answer is going to have the same bottom number. Okay? Now the top number, the numerator, is where the actual addition is. All you do is you take this number plus this number. So 1 plus 1 gives you 2. So what did we do here? We took the top number and we added it together, and the bottom number we just kept it from before. So now we have 2 over 2. And if you remember back from the last section when we were simplifying fractions, you can simplify this because 2 divided by itself is just going to divide 1 time. Okay? Fractions, even though I've been talking about them in terms of pi, okay, fractions are just another way of saying division. Okay? Here when I have 1 over 2, really what it means is 1 divided by 2. Okay? But since 2 cannot be divided into 1, okay, because we've already talked about the fact that in order to divide, you have to be dividing into a bigger number, okay? Because 1 cannot be divided into 2 an even number of times, it can't even be divided one time, this number is going to be less than 1, and so you just keep it as a fraction over here. You just keep writing it as a fraction. But over here, when you have 2 over 2, this is like division here. So 2 divided by 2, which is what a fraction really means, you can just do that, and you can make that a 1 there. And if that part doesn't make sense to you, then you can just remember it like this. Here's a fraction. I told you how to simplify fractions is pick a number on the top and the bottom. You can divide each number a whole number of times. So you can divide the top by 2, and you can divide the bottom by 2. And so that would come out to 1 on the top, 1 on the bottom, and that's just going to be 1. Either way you remember it, you can simplify 2 over 2, and that's going to equal 1. So what I'm proving to you here is, by pictures, 1/2 plus 1/2 surely does look like it would equal 1 whole pi. This is how you do it using the math. 1/2 plus 1/2, add the top number, keep the bottom number the same, and then just simplify the answer, and you're going to get 1 pi. Okay? Let's move on and work some other examples, because you're going to get the hang of this by seeing a lot of examples, and I'm going to help you through that. Okay? Adding and subtracting fractions really is not very hard, especially whenever you have the common denominator, which is what this section is. Okay? So the next problem, let's say, again, let's start drawing some pictures. Let's say I divide this pi into 4 pieces, and here's 1 piece, okay? So this is 1/4. 1 piece out of 4 total pieces, okay? And then over here I have another pi, okay, and I'm going to add to that, okay? And I'm going to have another piece out of this pi that I'm interested in. So this is 1/4, another 1/4, separate 1/4, and I want to add these two together. What is going to happen? Well, just by looking purely at the drawings, okay, what's going to end up happening is, okay, here is the piece from here, okay, and then this one, when I add it into this spot, is going to be the piece over here. Okay, so what I'm going to have is 2 pieces out of 4 total pieces. Okay, 2 pieces out of 4 total pieces. Okay. Now don't forget, you can always simplify fractions, right? Don't forget how to simplify this. You can divide the top by 2, and that's going to give you 1, and you can divide the bottom by 2, and that's going to give you 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So this is 1/2. And doesn't this look a whole lot like 1/2? Because here, if I were to divide the pie like this is half the pie, and this is half the pie. Okay? So, using the math, 1/4 plus 1/4. How did I teach you to do that? You just draw your division, your fraction bar. The bottom number is the same, so I can add these together. And I keep it. I just keep the 4. I don't do anything else. And then on the top, I just add 1 plus 1 gives me 2. Okay? 1 plus 1 gives me 2. And then we've already said here, I can simplify this and make this equal to 1/2. So if I were going to add this fraction together, this is exactly what you would write. This is the answer on the paper. This really does express the correct answer, but it's not fully simplified. So in all of your problems with fractions, you're going to have to get in the habit of simplifying them. Every time you get an answer, go ahead and see if you can simplify it. And we've done a lot of problems like that in the previous section. So go review that if you don't know how to do that. Add the top, keep the bottom. So you can see fractions really, I mean, they're not that hard. As long as the bottom is the same, you just keep the bottom and you add the top. And then you simplify. You simplify here. And the only reason I'm drawing these pictures is to kind of show you what you're doing here. You don't have to draw these pictures for every problem you solve. So you can see that it won't take that long to solve these problems. Okay? What if I had, okay, what if I had 1/4 again? Here's 1/4. Okay, 1/4. And then here's another pi over here. And let's say I'm going to take 1 piece here. Okay, 1 piece here, and 1 piece here. So here's 1, 2, 3 pieces out of a possible 4 pieces. Okay, and I want to add these up. What would be the answer in terms of pictures? What would be the answer? Well, here's 3 pieces, and if I add this piece in here, then basically the whole pie is going to be eaten, right? The entire pie is eaten, because here's my 3 pieces, here's the 4th piece, so all the pieces are there if I add them together. So it's 4 pieces out of a total of 4 pieces, and 4 divided by itself, 4 divided by 4 is just going to give you 1. Remember, a fraction is just, it's kind of like division, okay? But in these cases, you can't really do the division because you have 3 divided by 4. You can't really do that, so you'd leave it as a fraction. But in this case, 4 divided by 4, you know what that is. So just make it equal to 1. So this makes sense in terms of pictures. Let's go ahead and do it using the math. 1/4 plus 3/4. Okay? How did I teach you how to do that? You keep the bottom. Bottom is the same, so I can go ahead and add these. Okay? Keep the bottom. I don't do any addition on the bottom, but I add the top. 3 plus 1 gives me 4, and 4 divided by 4 we already said was 1. So without drawing any of this stuff, you could just do this and you would get the right answer. I'm just drawing the pictures to show you why it's the right answer. Okay? Let's go ahead and do one more problem using the pictures, and then after that we're going to drop the pictures and just go ahead and work a bunch of problems to practice. Okay? The next thing I want to talk about in the next graphical problem is that subtraction of fractions is really, really easy, and it's really almost exactly the same as adding fractions. So once you know how to add fractions, subtracting is really simple. So let's go ahead and look at an example of that. What if I had a pie like this, okay, and I divide it into 8 pieces? Okay, so here's 4 pieces, 6 pieces, 8 pieces of that pie, okay? And what if I take, here's 1 piece, here's 2 pieces, and then here's 3 pieces. 3 pieces of that pie. So 3 pieces out of a total of 8 pieces. So 3/8 is my fraction here. And let's say over here, here's a pie, and again I'm going to split it up into 8 pieces, like this. And I'm going to go ahead and just shade 1 piece here. What fraction is this? 1 piece out of 8. So 1/8. And let's say instead of adding, I want to go ahead and subtract these. So when you think about what you're doing here, you have 3 pieces out of 8, okay? And I'm subtracting 1 piece away. Well, how many pieces do I have left? Let's go ahead and draw it. If I had 3 pieces out of 8, and then I take 1 piece away, I'm only going to have 2 pieces left. So in the end, what I'm going to have in my picture is I'm going to have 2 pieces left. Because I started with 3 pieces out of 8, and I took 1 away. I subtracted this one out, and so I only have 2 left. So what is this fraction? This is 2/8. 2 pieces out of 8. Okay? Now let's go ahead and do this using the math. 3/8 minus 1/8. All you have to do is keep the bottom the same, exactly as before. If the bottom is already the same, keep it the same. Don't do any subtraction. And then you just take 3 minus 1. So you just go ahead and subtract the top, and that's going to give you 2. And that's what we already said we should have 2/8. But don't forget, you can simplify this, okay, because this can be simplified. How can you do that? Well, I can divide the top by 2, okay, and I can divide the bottom by 2. That's how I can simplify it. Remember, I can divide the top and the bottom by the same number, and that's how I simplify. 2 divided by 2 is going to give me 1, and 8 divided by 2 is going to give me 4. So that is going to be the answer to this problem, 1/4, fully simplified. Now, look at what we've done here. The answer is 2/8, okay? And we're saying that that is the same thing as 1/4. And you can kind of see that here because this is 2 pieces of the pie. But if you kind of consider this 1 piece, and then this 1 piece, and then this 1 piece, and then this 1 piece over here, then there would be 1 giant piece, 1 giant piece, 1 giant piece, 1 giant piece. That would be 4 giant pieces. And if you count this as 1 piece, that's 1 piece out of 4. So that's why it's 1/4. So this is an example of why 2/8 is the same thing as 1/4. It's expressing the same thing. Okay, there's no difference. So addition and subtraction of fractions are simple. Basically, you can only do it if the bottom number, which we call the denominator, is the same in both of the fractions you're talking about. And the second thing is, you just keep that bottom number and go ahead and add or subtract the top number. So let's go ahead and work some problems without drawing any pictures. What if you had 7/8 minus 2/8? How would you do that? First thing you need to check, is the bottom number the same? Yes, it is. Okay? So I just keep it the same. The top number, I just go ahead and subtract. 7 minus 2 gives me 5. 5/8. The next thing you need to ask is, can I simplify this fraction? No, I can't. There's nothing I can divide the top and the bottom by that's going to make that any simpler. So I'm done. This is the answer. Okay, what if you had 7/8 minus 3/8? First thing you check, is the bottom number the same? Yes, it is. So keep it there. I don't do anything else, just leave it there. And then on the top, 7 minus 3 is going to give you 4. You just subtract the top, you get 4/8. Then the question is there anything you can do to simplify this fraction? Yes, you can, okay? Because I can divide the top by 4 and I can divide the bottom by 4. And that'll make this a lot simpler. 4 divided by 4 is just going to be 1. And 8 divided by 4 is just going to be 2. So what we're saying is 4/8 is the same thing as 1/2. This would be the answer, 1/2. That's the simplest form here. Okay? We're just going to go through some rapid fire problems and get the hang of this. 2/10 minus 1/10. First thing you check, is the bottom number the same? Yes, it is. So I just leave it there. Don't do anything. Okay? And then 2 minus 1, I go ahead and do my subtraction. I get 1/10. And then you ask yourself, can I simplify this any further? No, because there's nothing else I can divide the top and the bottom by that's going to make that any simpler. Okay? So you see, working through the problems here, it really isn't that hard. Fractions just look a little bit different than regular numbers, but once you know the rules, it's really not hard. What if I have a little bit bigger fraction, 5/16 plus 8/16? Okay, what would that equal? First thing you do is you see, is the bottom number the same? And the answer is yes, it is. So I leave it there. I don't do anything different. I just write it down. And then since we're adding, I just take the two numbers on the top and add them together. 8 plus 5 is going to give you 13. You can do that on your fingers. And you can write a 13 up here. And then you need to ask yourself, can I simplify this anymore? No, I can't think of anything I can divide 13 and 16 to make a nice number. So I'm done. This is the answer. Okay? 5/12 plus 6/12. Okay? First thing you do, do I have the same number on the bottom here? Yes, you do. So you just keep it. Don't do anything special. And then on the top, I'm adding, so I just take 5 plus 6, and you can do that on your fingers, and you'll see that that's 11. 5 plus 6 is 11, and so you have 11/12. And is there anything you can simplify that and divide the top and the bottom? No, nothing I can think of, so you're done. That's your answer here, and that was your answer here. Here we have 1/12 plus 3/12. First thing, yet again, is the bottom number the same? Yes, it is, so keep it there. And the top number is 1 plus 3. It's going to give me 4, okay? And then always at the end, you always have to ask yourself, can I simplify this? And I say, yes, you can, because I can divide the top by 4 and the bottom by 4. And that's going to make things simpler. Let's see how. 4 divided by 4 on the top is going to be 1, and 12 divided by 4 on the bottom is going to be 3. 12 divided by 4 is 3. 1/3 is a whole lot simpler than 4/12, so I say we're done. Okay? So really, it just becomes a very mechanical thing. It becomes very much, repetition after a while. I'm going to do 2 more quick problems. What if you have 3/10 minus 1/10? First thing you do is you look at the bottom and you say, well, is the bottom the same? Yes, it is. The top, you say, okay, well, I'm subtracting, so 3 minus 1. That's going to give me 2. And then just like always, you have to look and say, can I simplify this? And I think we can, because we can divide the top by 2 and the bottom by 2. And let's just see if that's going to make things simpler. 2 divided by 2 is just going to be 1. Anything divided by itself is 1. And then 10 divided by 2 is going to be 5. 1/5 is a lot simpler than 2/10, and that's as low as I can go, so that's going to be it. And the last problem in this section I'm going to say is going to be 5/18. 5/18 plus 1/18. Okay? First thing, you just look and see, is the bottom number the same? Yes, it is. So keep it. Don't do anything. And the top number, you just add together. 5 plus 1 gives you 6. And then just like always, we want to see if we can simplify this anymore, and I think we can. 6 we can divide the top and the bottom by 6, and we can divide the bottom by 6. And let's just see if that makes anything better. 6 divided by 6 is 1. And on the bottom, 18 divided by 6 is going to be 3. And I know this because 6 times 3 is 18. So we end up with 1/3. So to summarize, adding and subtracting fractions is not that difficult, especially when the bottom number, which we call the denominator, is the same. And to summarize, in order to add or subtract fractions, the bottom number, the denominator, must be the same between the two fractions. If it's not the same, you can't add them until you do a little bit of work first. We're going to talk about that later, okay? But when they are the same, you just keep the bottom number, don't do anything to it, and add or subtract the top numbers. And then when you get the answer, you just see if you can simplify it like we did here, and we practiced how to simplify fractions already, so that's a skill you already know how to do. And that is how you add and subtract fractions. It's really not that difficult. Hi, and welcome to this section of the class where we're going to continue working with fractions. We're going to continue learning how to add and subtract fractions, but this time the problems are going to be a little bit more difficult in the way that the denominators are set up. So in the previous section we said that in order to add or subtract fractions, the denominator, which is that bottom number, has to be the same. It's the only way you can do it. If they're not the same, we have to do a little bit of work first. It's not going to be hard. We have to do a little bit of work. And so here in this section, we're going to talk about those kinds of problems, and we're going to learn how to do that. So let's go ahead and, like I like to start these sections out, draw some pictures and understand what we're doing. Let's say you have a pie here, okay? And here's half of a pie. We said this is half, one piece out of two possible pieces, okay? Now let's say over here, I want to add something to it. So I'm gonna end up adding something here. But what I'm gonna add, okay, is not gonna be a half, it's gonna be 1/4. Okay? One piece out of four possible pieces. Now, question is, how do you do this? You don't know how to do this because the denominator is not equal. The denominator is not equal, okay? This number is not the same as this number. We said in order to add or subtract fractions, the bottom numbers have to be equal. In this case, they're not equal. So what do you do? Well, I'm going to show you what to do, and it's going to be really cool. It may seem a little bit confusing at first, but I promise you it's going to be better. What we're going to do is we're going to change this problem, okay? So this was our original problem, okay? This was our original problem. But what we're going to do is we're going to change the problem a little bit, and we're going to make it so that these bottom numbers are the same. How do you think we can do that? Well, let's go ahead and let's change this first fraction a little bit. Just stay with me. I promise you will understand this, okay? This is half of a pie, okay? And we all know that. We can cut it in half. But let's go ahead and cut it into 4 pieces instead of in 2 pieces. And then what if we took this piece away here and this piece away here? Okay? What would we have here? Okay? Well, we would have 2 pieces out of a possible 4 pieces. So we would have 2 out of a possible 4 pieces. 2 out of a possible 4 pieces. Okay? Now, what if we just left this part the same as in our original problem, and we would have 1 piece here out of a possible 4 pieces, so this would be 1/4, 1 piece out of a possible 4 pieces. Now I'm asking you the following. I tell you that these 2 problems are exactly the same, okay? I mean, when you look at it, here I have this much pie, and here I have the same amount of pie. Here I have this much pie, I have the same amount of pie. So in terms of pie, in terms of how much pie is on the table, it's the same, okay? This is the same amount of pie as this, even though the fraction looks a little bit different. And this is exactly what I was telling you before. Fractions can look a little bit different, but they might be the same, and that's why we always simplify things. If you were to try to simplify this fraction, divide the top by 2 and the bottom by 2, you would get 1/2, which is what this fraction is. All I'm telling you is I'm writing this fraction in a different way. The reason I did that, can you guess why I did that? I did it because I want these two bottom numbers to be the same. Then I can add these fractions together. That is the secret to adding fractions. You want to change the problem so that the bottom numbers are equal. That is the only reason we did this. Otherwise, there'd be no reason to do it, okay? So, if we did this, if I took this and added it to this in picture form, okay, I would have this pie cut into 4 pieces. I'd have this piece from over here, okay, and then this half of the pie over here, I'd have a piece here, and I'd have a piece here. So I'd have 3 pieces out of a possible 4 pieces. 3 pieces out of possible 4 pieces. And notice, that makes absolute sense with my rules. The bottom numbers are the same, so I keep my bottom number. The top number, I just add to each other, and I get 3/4. 2 plus 1 gives me 3. Okay, so as we go farther along, we're not going to have to draw all this stuff every time, but I'm just showing you what we're doing. We're taking a problem that has different denominators, and we're changing it. The only thing we did is we just changed the way the fraction looked. The only reason we did that was to get the bottom numbers the same, then we can add our fractions. And we do that using the same method that we learned in the last problem, in the last section. Okay, so once you know how to change the fractions to get it into the right form, then you can go from there. Now this whole process is called finding the common denominator. What you want to do is you want to find a denominator between the two fractions and make them the same. Then you can add them or subtract them. That's called finding a common denominator. Okay, now I've set another problem up on the board, and what I want you to do is ignore this and just look at the top part of the screen for a second. Here I have a pie. I divided into 8 pieces, okay? 8 pieces. I have 7 of the 8 pieces here, 7/8, okay? Now what I want to do is subtract from it another pie, and this one is 3/4, 1, 2, 3 pieces out of 4. How would you do that? Well, the first thing you know is that the bottom numbers, the denominators, are not the same, so you can't subtract them. So that's why I have here the denominators aren't equal. You don't know how to do that. So what we're going to do is we're going to change the problem into what I have down here, and that's what this arrow means. I'm going to keep this top one the same, 7 pieces out of 8, that's 7/8. And what we're going to do is we're going to change this problem. We're going to make a pie with 8 pieces, and we're going to shade 1, 2, 3, 4, 5, 6 pieces, 6/8. Now one thing I want to tell you is that even though this fraction looks different than this one, this is the same amount of pie as this, and you can kind of see that. Here's this much pie and here's this much pie. Even though it's a different fraction and it looks a little bit different, it represents the same amount of pie. And you could see that if you were to simplify this fraction. 6 divided by 2 would give you 3, 8 divided by 2 would give you 4. It's the same amount of pie in each case, okay? So now that we have this new problem transformed here, we can actually do the subtraction. 8 is the same number as 8, and that's what allows us to go ahead and move forward, and that's why we did this in the first place. Okay, but if we were going to have 7 pieces out of 8 and subtract 6 pieces, well, how many pieces will we have? 7 pieces here, and there's 6 pieces I'm taking away, so all that I'm going to have left, okay, over here, is just going to be 1 piece of pie. Because here I had 7 pieces out of 8, and I'm taking away 6 pieces. So I'm only going to have 1 piece out of 8. And that makes a lot of sense when you look at how I taught you how to subtract fractions. The bottom number is the same, so I keep it here. The top number, you take 7 minus 6, and you get your 1 piece. So that was a problem where we found the common denominator in order to subtract a fraction. Now, up to this point, I've been drawing a lot of pictures and showing you and proving to you that what you're getting here is the same fraction, and so we can go ahead and move forward. From now on, we're not going to draw any more pictures, and I'm going to show you how to do this common denominator stuff in your sleep. What if you have 1/2 plus 1/6? First thing you need to say is, are these two numbers the same? No, they're not. So you have to do something to them in order to be able to add the numbers, okay, to add the fractions. I told you before you can do the same thing to the top of a fraction and the bottom of the fraction as long as you do the same thing. So let's go ahead and do that now. What if we multiply the top of this fraction by 3 and the bottom of the fraction by 3? We're doing the same thing to the top and the bottom, so we're not doing anything illegal. But let's see what that would give us. What this would do would be 1 times 3 would give me 3, 2 times 3 would give me 6. And then if we're going to continue to add the 1/6, you see what we have done is we've changed the problem into a problem. Now we have the same bottom numbers, and we can go ahead and continue. Since the bottom is the same, we just keep it as a 6. 3 plus 1 is 4, and we've done that before. And here, it just becomes the same old stuff as last time. You always check, can I simplify this? Sure I can. I can divide the top by 2 and the bottom by 2. And that will simplify this fraction. 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. So the answer is going to be 2/3. Now that looks pretty complicated, but just remember, what you're going to end up doing anytime you have two fractions that look different in the bottom, try to find a number that you can multiply both top and bottom to make the bottom number the same as this one. And then go ahead and write that down, and then the problem becomes the same as before. There's only one more step added. You have to multiply the fractions in order to get a numerator, denominators that are the same. Every now and then you'll have to multiply both fractions by something to do this, but for these problems here, we're going to keep it simpler. Let's work some more problems. I think you'll get the hang of this. 3/8 plus 1/16. 1/16, okay? What can I multiply this fraction by that would give me a 16 on the bottom? Well, I know that 8 times 2 is 16, okay? So 8 times 2 is 16. I got to do the same thing to the top, okay? So what's my new problem going to be? 3 times 2 is going to give me 6. 8 times 2 is going to give me 16. And of course, I'm adding to it 1/16, okay? And so now the bottoms are the same, so I can just keep it just like before, and then 6 plus 1 gives me 7. 7/16. And there's nothing I can do here to simplify that anymore. Okay? We're just going to work a lot of these problems. 7/8 plus, let's go ahead and do minus 1/2, just to go ahead and give you a flavor for that. Now, what can I do to make these two fractions have the same bottom? Well, I know I can multiply this bottom number by 4, okay, and that would give me 8. That's what I'm trying to match, okay? So I have to do the same thing to the top and the bottom, okay? So what I'm going to have in the end is I'm going to have 7/8, because I didn't do anything to that, minus, on the top I have 1 times 4, gives me 4, and on the bottom I have 2 times 4, and that gives me 8, okay? So at the end of the day, I'm going to have the bottom number is the same, so I keep it. The top number is 7 minus 4. Subtract, you get your 3. 3/8. Okay? Not that hard, especially if you have mastered how to add fractions from the previous section. You're only doing one more step, and that is finding that common denominator. You just have to pick a number, multiply top and bottom, and go from there. What if you have 9/10 minus 1/5? Okay? Well, 9/10 minus 1/5. I know that I can multiply this number times 2, and that'll give me a 10. So we're going to change the problem. Okay, and what we're going to do is we're going to multiply the bottom times 2 and the top times 2. Why are we doing that? Because we want to try to make the bottom of this equal to 10. 1 times 2 gives me 2. 5 times 2 gives me 10. Now our problem has the same denominator. We can go forward. Keep the bottom. Don't do anything different. 9 minus 2, you're going to find that that's going to give you 7. So the answer is 7/10. Okay? What if you had 2/3 minus 1/2? 2/3 minus 1/2. Well, here, this problem is a little bit trickier because there's nothing I can, there's nothing I can multiply this bottom number to give me a 2, and there's nothing I can multiply this bottom number to give me a 3. So I'm not going to be able to just multiply one fraction, but what I know that I can do is, just follow along with me here. If I multiply this guy by 2, and of course do the same thing by the top, and then if I can do the same thing to the other fraction, but pick a different number, I can multiply this by 3 and this by 3. Let me go ahead and make this clear. Multiply this by 3. I'm going to come back and explain everything in a minute, but let's go ahead and figure out what that would do. 2 times 2 would give us 4. 2 times 3 would give us 6, and I'm subtracting. Here, 1 times 3 would give me 3. 2 times 3 would give me 6. Now look at what I've done. I have the same common denominator, and I can go ahead and finish the problem. Okay, so let's go ahead and do that. In the bottom you have a 6. In the top you have 4 minus 3 gives you 1. So that's the answer. What I want to show you here is that you don't have to multiply both fractions by the same number. All you have to do is make sure the top and the bottom are multiplied by the same number here, and the top and the bottom are multiplied by the same number here. So a guaranteed way to get a common denominator is just multiply by the other denominator. 2 over 2, and then here multiply by the other denominator, 3 over 3. And when I did that, I knew that 2 times 3 was going to give me 6, and I knew that 2 times 3 was going to give me 6. So I picked my numbers so that my common denominator is now 6. Then I could finish solving the problem. Let's do a couple more problems, and I think you'll get the hang of this. 3/4 minus 1/3. Again, there's no single number I can multiply by that'll make this bottom a 3, and there's nothing I can multiply this by, this bottom number, to give me a 4. So I'm going to have to multiply both fractions by something, and it doesn't have to be the same number. What I'm going to do is I'm going to multiply this by this denominator over here. It's going to be a 3, and I've got to do it to the top. And then here I'm going to multiply this by this denominator, which is going to give me a 4. Okay, so all I'm doing is I'm multiplying the fractions by the other denominator, and let's see what that will do. Okay, let's see what that will do. 3 times 3 is going to give me 9. 3 times 4 is going to give me 12. Subtracting, top is going to be 1 times 4 is going to give me 4. Bottom, 3 times 4 is going to give me 12. So you see, what we've done is we've changed this problem. Now we have the same common denominator. So the bottom's going to be 12, and the top's going to be 9 minus 4, which is going to give you 5/12, and that's the final answer. So the trick here is if you can't figure out what number to use, just multiply this fraction by the denominator of this one, and multiply this fraction by the denominator of that one. Doing that will always make sure that you have, in this case, for instance, 3 times 4 gave me 12. Here, 4 times 3 gave me 12. All I care about is that the denominator is the same. I really don't care what I multiply by. That can be anything. I just want to make sure that in the end my denominators are the same. That's all I'm trying to do. Okay? So it may take you a few tries to figure out what to multiply by, but once you get it, then the problem's simple. Let's say 1/6 plus 1/8. Again, I'm trying to find a number that I can multiply these fractions by to give me a common denominator. Well, I'm just going to go ahead and, by example, multiply this guy by 4 and this guy by 4. That's going to give me 6 times 4 is 24, okay? Now I know that 8 times 3 is also 24, so I'm going to go ahead and use that one and multiply by 3. The reason I did this is because I want to make 24 in the bottom over here and 24 in the bottom over here. 4 times 6 is 24. 8 times 3 is 24. Okay? So let's go ahead and do this. 4 times 1 gives me 4. 4 times 6 gives me 24. 1 times 3 gives me 3. 8 times 3 gives me 24. So I've done what I want to do. I've got the same common denominator. So I keep 24 in the bottom. Don't change that. 4 plus 3 gives me 7. So the answer is 7/24. So it may take you a minute to pick something, and it takes practice, that's why I'm doing these, to pick something that's going to be able to give you a common denominator. Last problem we're going to do is 3/10 plus 1/3. Okay? Again, different denominators, so we're going to have to do something. What I'm going to do is, I know that 10 times 3 is going to give me 30, so I'm going to do this. So 30 will eventually be over here. And then if I take 3 and multiply times 10, that will also give me 30. So that's going to be my common denominator. 3 times 3 in the top gives me a 9. 3 times 10 gives me a 30. And I'm adding to it 1 times 10 gives me 10. And 3 times 10 also gives me 30. So you see I picked my numbers here. Here I multiplied by the other denominator here. And this one I multiplied by the other denominator. And that tells me that I'm always going to have a common denominator here, because 3 times 10 gives me 30, and 10 times 3 gives me 30 here. So in the final answer, you just leave 30 in the bottom. 9 plus 10 gives me 19, which you can't simplify anymore. So adding and subtracting fractions when you don't have a common denominator isn't really that hard. You just need to work with the fractions ahead of time to make the denominator equal. And the way you do that is you pick numbers that you can multiply the top and the bottom by in order to change that bottom number into what you want. And then if you may have to do it to two fractions in order to get both fractions to have the same common denominator. And then once you have the same common denominator, you just add them up and keep the same bottom. And that is how you add and subtract fractions when you don't have a common denominator. Hi, and welcome to this section of the tutor where we're going to continue working with fractions. This time, we're going to talk about how to multiply fractions. Just don't forget, fractions are just another number like anything else. They look a little bit funny because you have that bar there and the number on the top and the number on the bottom, but they're just a number. And specifically, a fraction is a number that's pretty much going to be less than 1. Okay, so anytime you have something less than 1, you're going to be dealing with the fractions. And because it's just a number, you can add, subtract, multiply, and divide them. And we've already tackled the adding and subtracting, and now we're going to talk about multiplication. Okay, the way to do that, the best way is to go ahead and just talk about an example. Okay, what if you had, here's a fraction. Of course, in this case, I'm just making a special case. So what I have is a pi here, and I have the entire pi. Okay, so this is just 1 pi. This is the number 1, right? Okay, it's not really a fraction, it's just a number, 1 whole pi, okay? And let's say I'm going to multiply it by another fraction, and I'm just drawing the fractions for you here on the board so you can visualize it. And this is half of a pi. So this fraction is 1/2. And I'm going to put a little dot here, and this dot means multiplication. You can use a dot or you can use an X, whatever, it's the same thing. It just means I'm multiplying these two things together, okay? One thing I want you to understand is that a fraction is kind of like a hatchet or an axe, okay? And what does that mean? A hatchet is something that you go up to a tree and you chop it, and the tree, you can chop it down, right? You can chop something down. A fraction is kind of like that. When you multiply a fraction times a number, this fraction is going to end up chopping the first number down, okay? And you'll see what I'm talking about here as we go forward. Here I have 1 pi, and I'm multiplying by 1/2 of a pi. So what this really means is I start with 1 pi, and I'm only going to take half of it away. I'm multiplying by 1/2, so in the end, what I'm trying to do is I'm trying to take 1/2 of this first pi, and that is going to give me the answer. Okay, as we work through some more problems, you'll understand what I'm talking about here, but the first number is just what you're starting with, and the fraction that you multiply by is basically telling you how much of this first pi am I going to be left over with, okay? So here I'm multiplying by 1/2. So in the end, all I want is half of this first pi. So if I start with a pi, and this is telling me I just want to end up with half of what I started with, then the final answer is just going to be 1/2. Okay, here's a pi, here's 1/2. Okay, so the answer is 1/2, okay? Because I start with 1 pi, and I multiply by 1/2, and that means that in the end, all I'm trying to do is take 1/2 of what I started with. 1/2 of what I started with here is just 1/2, okay? So that's how you do it in terms of pictures. Now, how do you do this in terms of math, okay? You start out with 1, okay, and you're multiplying by 1/2, okay? Well, in order to multiply fractions, you have to write everything in terms of a fraction. What would 1 be written as in terms of a fraction? It would be 1/1. Because don't forget, anything divided by itself is just 1. So 1/1 is exactly the same thing as 1. Okay? And I'm going to multiply by 1/2. This dot just means multiply. The good news is, multiplying fractions is really easy. It's actually easier than adding them, okay? In my opinion, it's actually easier than adding them. And let me show you how. Anytime you have a fraction, multiplied by another fraction. No matter if the bottom number is the same or not, all you have to do is you multiply the top two numbers together. So let's do it. 1 times 1 gives us 1, and then you draw your bar, and then on the bottom you just multiply the bottom two numbers. 1 times 2 gives you 2. Okay? So remember back when we added and subtracted fractions, the bottom number had to be the same in order to do that. For multiplying, and later on you'll see dividing fractions as well, it doesn't matter what the bottom number is. So that's why it's actually a little bit easier. You just take the top number, multiply by the other top number, you get this number on the top. Bottom number times the bottom number gives you the other bottom number. Now notice we did this and we got the answer of 1/2, which is what we said we should get based on what multiplication by fractions really is. So let's go ahead and work through some other problems. You know, we'll do some problems where I draw it on the board, and I'll kind of try to explain to you what you're doing when you're multiplying by fractions. And we'll go from there, okay? What if you had 2 pies to start with? So here's a pie, and here's another pie, okay? And I'm going to go ahead and shade the whole thing to remind you that this is the whole pie we're talking about. So this really isn't so much a fraction, it's just a number. 2 pies, okay? And I'm going to multiply this 2 by the same thing we did in the last problem, just so we can kind of get a feel for it, by 1/2. Now, kind of just using the big rules of fractions and what it really means, what are we trying to do here? We have 2 pies to begin with, and this is telling me when I multiply that really all I want is half the amount what I started. Well, if I have 2 pies to begin with, half of these 2 pies is just going to be 1 pie. I mean, when I start with 2 pies in my hand, one in this hand, one in this hand, and then I'm just going to take half of them, okay, which is what this is telling me. When I multiply by 1/2, I'm just going to throw half of them away, and then the answer is going to be what am I left with, okay? Then, well, if I have 2 pies and I throw half of them away, I'm only going to throw 1 pie away. I'm going to have 1 pie left over, okay? So the answer in this case would be 1 pie. 1 pie. Start with 2 pies. When I multiply by 1/2, it's telling me throw half of these pies away, okay? And what I'm left with is going to be 1, because obviously if you start with 2 and you throw half of them away, you're only going to have 1 left over. Now let's do this in terms of the math, okay? I have 2 times 1/2. Now anytime you have fractions you're multiplying, you have to write everything as a fraction. What would 2, the number 2, be written as a fraction? That would be 2 divided by 1, 2 over 1. Remember, anything divided by 1 is just itself. So anytime you have a number, you can just put a 1 on the bottom here, and then that's the correct fraction. 2 divided by 1 is going to be itself. So 2 over 1 is the right fraction here. We're going to multiply by 1/2. Okay? So now all we did was we wrote 2 in terms of a fraction. Okay? And then what we do to find our answer is we just take the top 2 numbers and multiply. 2 times 1 gives us 2. And the bottom 2 numbers, 1 times 2 gives us 2. So the answer is 2 over 2, but don't forget fraction is kind of like a division, right? So 2 divided by 2 is going to be what? If you remember back from your division, 2 divided by 2 is going to be 1. So the answer is 1, which is exactly what we thought we should have based on that. So I'm just trying to draw in terms of pictures what you're going to get here, but the math here is really simple. Multiply the top, you get this, multiply the bottom, and then you just simplify this fraction like we've been doing all along. Okay, let's do one that's a little bit, you know, maybe not quite so obvious. We're going to go and do another one here. What if you start out with 1/4? Remember, how do you write 1/4? You draw your pie, 4 pieces. Here's 1 piece. So 1 out of 4 pieces. There's 4 pieces total. 1 out of 4 pieces. That's 1/4. Okay? And now I'm going to multiply by, again, 1/2. I'm multiplying by the same thing to kind of give you guys a flavor for what you're doing here. Here's 1/2. Okay? You're multiplying here. Now, forgetting about the math for a second, what do you think this is going to do? What this is telling me is here's a number I start with, and I'm multiplying by 1/2. So in the end, what I'm asking myself to do is take what I start with, chop it in half, because that's what we're multiplying by, and throw that side away. All I want is half what I started with. So if I start with something like this, then half of that is going to be something like this. Okay? So all I'm going to want is something like this. That's about half of what I started with. Okay? It's about half of what I started with. So let's see what would happen if we actually multiplied these fractions. 1/4 times 1/2. Remember, it doesn't matter if the bottom numbers are the same or not. It's really easy. Top number 1 times 1 gives you 1. Bottom number 4 times 2 gives you 8. So we think that when we multiply this, you're going to get 1/8. And let's see what 1/8 is going to look like over here. Let me go ahead and divide my pie into 8 equal pieces. Okay? 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to take one of those pieces because that is 1/8. Now look at what we have here. I started out with 1/4, which is this much pie. I multiplied by half, and that just meant basically take what I start with, chop it in half, and that's all I want to have left over. And then the answer that we calculated was 1/8, which we drew over here, and this does look like about 1/2 of what I started with here, okay? So when you multiply by a fraction, when you think about it, what is multiplication, okay? You know what multiplication is in general. When you multiply by 2, something by 2, the number gets bigger. Like 2 times 4 is 8, okay? When you multiply by 10, the number gets even bigger. When you multiply by 100, the number gets bigger. But as you start getting closer to 0, when you start to multiply by 1, like 2 times 1 gives you 2, 3 times 1 gives you 3, 4 times 1 gives you 4, stuff like this. When you multiply by 1, well, the number doesn't change because anything times 1 is itself. When you multiply something less than 1, which is what a fraction is, okay, then what you're doing is you're chopping it. You're not making it bigger anymore, you're chopping it down like a hatchet. So what I'm doing is I'm multiplying by 1/2, I'm chopping this down, whacking it in half, and that is what I get over here in the end, okay? So we're going to do one more example using the pictures here. And then after that, we're just going to work a bunch of problems without pictures, okay? So what if I start with 1/2 over here on the left? Okay, here's my 1/2. And what I'm going to multiply by, I'm going to multiply by 3/4. So here's 1/4 here, here's 2/4 here, and here's 3/4 here. So 3/4. Okay? Let's go ahead and do it with the math and see what we would come up with and see if that kind of makes sense. 1/2 times 3/4. Remember, it doesn't matter if the bottom number or the top number is the same. It's real easy. 1 times 3 gives me 3, and then that's on the top, and then 2 times 4 gives you 8. So the answer is going to be 3/8. Really simple, okay? Really simple. So how would we draw 3/8? Well, first we got to chop into 8 pieces, just like before. Here's 4 pieces, 6 pieces, 8 pieces. And we're going to take 3 out of those 8 pieces. So here's 1, 2, 3. Here's 3/8. 3/8, okay? So what have we done? Does this make sense? Does this make sense? Yes, it does make sense. You start out with 1/2, which is about this much, okay? When you multiply by 3/4, what you're telling yourself is, I'm going to chop this down a little bit, okay? That's what multiplying by a fraction does. I'm going to chop it down, and I only want to keep 3/4 of what I started with. Now, 3/4 is almost the whole thing. You see, here's a whole pie here. 3/4 is almost there. It's about 3/4 of the way. It's 3/4 of the way around. So of this first piece, I only want to keep about 3/4 of what I started with. So in other words, I want to keep most of it, but not all of it, okay? And so if you look at what we found in the answer, here would be a half all the way down. Well, we kept almost all of it. 3/8 of it right here. We kept almost all of it. But we didn't keep everything, and that's because we were multiplying by 3/4. We chopped it down a little bit, and we're only keeping a little bit left over. Okay? So that is kind of an introduction to how to multiply by fractions. And what we're going to do now is we're going to work a bunch of problems, and we're not going to draw any more pictures. We're just going to kind of work through a bunch of problems to get some practice. What if you had 1/3 times 2/5? How would you do that? Multiply the top. 1 times 2 gives you 2. Multiply the bottom. 3 times 5 gives you 15. And don't forget to always check and see if you can simplify this. And in this case, you can't simplify that anymore, so you're done. What if you had 1/5 times 3/10? Okay. You multiply the top. 1 times 3 is 3. Multiply the bottom. 5 times 10 gives you 50. Again, you can't simplify that anymore, so you're done. What if you had 2/3 times 3/4? Multiply the top. 2 times 3 gives you 6. Multiply the bottom. 3 times 4 gives you 12. Always check and see if you can simplify the fraction. In this case, you can, because you can divide the top by 6 and the bottom by 6. As long as you're doing the same thing to the top and the bottom, you're okay. 6 divided by 6 would give you 1, and 12 divided by 6 would give you 2. So the final answer here would be 1/2, okay? 1/2. Okay, now what if you had, just kind of going through some more problems here, 1/4 times 2/3? Very simple. Multiply the top. 1 times 2 is 2. multiply the bottom. 3 times 4 is 12. Ask yourself, can I simplify the fraction here? Yes, you can, because you can divide the top by 2 and the bottom by 2. As long as I'm doing the same thing to the top and the bottom, that's okay. 2 divided by 2 is going to be 1, and 12 divided by 2 is going to be 6. And this is as simple as you can get, 1/6. What if you had 4/5 times 6/8? Again, multiply the tops. 6 times 4 is 24. Multiply the bottom. 5 times 8 gives you 40. And then you always have to ask yourself, can I simplify? Yes, I can. I know that I can divide the top by 2, so I'm going to do this. I'm going to divide the top and the bottom by 2, and I'm going to see where that gets me. 24 divided by 2, you can figure out by looking at your times tables, is going to be 12. And 40 divided by 2, you can figure out, looking at your times tables, is going to be 20. So I've got 12/20ths. Question is, can I simplify this anymore? Well, you can, because you can divide the top by 2 again, and you can divide the bottom by 2. Let's see if that gets us as simple as we can go. 12 divided by 2 is going to be 6, and 20 divided by 2 is going to be 10. You can do all your multiplication tables and figure that out. And then the final thing is to see, well, can I simplify it more? And you sure can. You can divide by 2 again, and you can divide by 2 one last time. So 6 divided by 2 is going to be 3, and 10 divided by 2 is just going to be 5. Now that's a lot of dividing by 2 there, but just don't forget to check at each step to see, can you divide by 2? Can you divide by something to make it simpler? In this case, we had to do it a few times. And finally, if you had 6/10 divided by 3, or times 3/4, same thing as always. The top number, 6 times 3, from your times tables is 18, and 10 times 4 is just going to be 40, okay? 18 over 40, and then you ask yourself, well, can I simplify this? And you can divide the top by 2 and the bottom by 2, okay? Most of the time, you know, you can divide these things by 2 a lot of times anyway. So 18 divided by 2 is 9. So here again, 18 divided by 2 is going to give me 9. And finally, 40 divided by 2 is going to give you 10. And you can't simplify 9/10 anymore. You just can't do anything more with that, so you're done at this point. So multiplying fractions, there's two main things in this lesson that I wanted you to understand. Multiplying by a fraction, which is basically the same thing as multiplying by a number less than 1, isn't going to make the initial number get bigger. It's going to make the initial number get smaller. So when we're looking at those pies earlier, you start multiplying by fractions. Well, what you're doing is you're taking a portion of that first number, and that's going to be your answer. So you may be chopping it in half, you may be chopping it in quarters, or whatever. So you're chopping it down. The second thing is actually multiplying the fractions is really easy, because it doesn't matter if the bottom number is the same, like we had to worry about with adding or subtracting a fraction. So you just multiply the top two numbers, like we were doing here, and that'll give you this number, and you multiply the bottom two numbers, and you get that bottom number, and then just like always, you just see if you can simplify it, and sometimes you may have to simplify many, many times, and you may have to know your multiplication tables really well in order to be able to do that. But in the end, it's not that difficult. Multiplying fractions is something you just need to practice. Hi, and welcome to this section of the tutor, where we're going to continue again working with fractions. And in this section, we're going to learn about how to divide fractions. The good news is that if you know how to multiply fractions, which is what we covered in the last section there, dividing fractions is really, really easy. It's really almost exactly the same thing as multiplying fractions. So if you don't know how to multiply them really well, go back and watch that section. But once you know that material, this material is going to be a piece of cake, I promise you. So what we want to do is we want to look at some problems that would look something like this. If you had 1/6 and you were dividing by 1/2, okay? 1/6 divided by 1/2. Well, let's rewrite that a little bit, and I'll show you what they're really asking. You have 1/6, which is just a number, don't forget, and I'm dividing by, which is what this big bar means, I'm dividing by 1/2, okay? So here I've got 1/6 divided by 1/2. Here I've got 1/6 divided by 1/2. I'm just showing you what they're really asking you to do. I'm kind of writing it in a different form, okay? 1/6 divided by 1/2, okay? The way in which you do division of fractions is very, very simple. You just take the top number, 1/6, and you change this division, which is this big line here, into multiplication. But when you do that, so you change it into multiplication, so you put a big dot here, that means multiplication. But you're not going to multiply by half, you're going to multiply and you're going to flip this fraction over. So you're going to multiply by 2 over 1. Okay? Now I know that that may not make a whole lot of sense, but that's really what you're doing. We'll go back and talk about this part in a minute. Let's go ahead and finish the problem. Now that it's a simple multiplication problem, you just multiply the top two numbers. 1 times 2 gives you 2. And the bottom two numbers, 6 times 1 gives you 6. And then just like any problem with anything, you always check and see if you can simplify it. And here you can, because you can divide by 2 and you can divide by 2. Okay? 2 divided by 2 is going to give you 1. 6 divided by 2 is going to give you 3. Okay? So that's the answer, 1/3. Notice that from here on, it was just a simple multiplication problem. You just multiply the top, multiply the bottom, simplify the fraction, and that's it. The only thing that you need to know here is when you're dividing, okay, you take the top number, and then you change this division into a multiplication, and then you take the bottom fraction and you flip it over, which is what we did here. 1 over 2 became 2 over 1, and then you can multiply them. So you see, division and multiplication are kind of almost opposites of one another, and they're almost exactly the same. And once you start, okay, with the division, you can change it into multiplication by taking that bottom fraction and flipping it over, and then you can multiply. So it's really, really not very hard, okay? And I'm trying to build up to it here and kind of teach you the things that you're going to need to know. But what if you had something like 2/7, again, divided by 1/2? Well, it helps me when I'm writing it down to go ahead and write it as 2/7 all divided by 1/2, which is just a number divided by another number, okay? It helps me because whenever I write this down, I can write it as 2/7 times, changing it into a multiplication, I take this bottom fraction, flip it over, and write it over here. 2 over 1. 1/2 becomes 2 over 1. Okay? Now, you don't really need to write this down. I mean, you could start from here and you could just write this first number down, put a multiplication, and flip the second number down. That's fine. It's just, I get in the habit of doing it this way. It's just something for me, mainly. So then you just go and take the top two numbers. 2 times 2 will give you 4. Okay? And the bottom number times the other number is 7 times 1 is going to give you 7. So 4/7 is the answer. There's nothing more I can do to simplify. So you're done. So division of fractions really isn't that hard, but it does give a lot of people a lot of problems at first. Okay? So what I like to do again is I like to write 5/8 on the top, all divided by, and then 3/4 on the bottom. Okay, you don't have to write this, but I like to do it. And then finally, to solve the problem, 5/8 times, take this bottom fraction, flip it over, so it's going to be 4/3. So you take the bottom fraction, flip it over, and change it to multiplication. So it's real easy. 5 times 4 is going to give you 20. Okay, and 8 times 3 is going to give you 24. So like anything else, you need to go and say, well, can I simplify this anymore? Can I do anything special with this? Okay, well, you can divide the top and the bottom by 4. Okay, and when we do that, I believe it's going to simplify the problem here. So I think we can simplify this. 20 divided by 4 is going to be 5, and that's just because 5 times 4 gives you 20. And over here, 24 divided by 4 is going to give you 6, simply because 4 times 6 gives you 24. So you're going to have 5/6 as the answer. But notice from here on over to the right, it's exactly the same as the last section, which is just a bunch of problems in multiplication. So I'm not going to do a whole lot of problems in this section. We're going to do a few more here. But because it's so very simple, I mean so very similar, that's what I meant to say, to multiplication, we're just going to do a few problems to kind of get us in the hang of it. 3/5 divided by 2/3. Okay? And I like to write 3/5 on the top, all divided by 2/3. So I'm just rewriting the problem here. So now in order to go on, I just write 3/5 times, take this bottom number and flip it over, 3/2. Just flip it over like this. And I can change it into multiplication. So then 3 times 3 gives me 9, that's on the top. 5 times 2 gives me 10, which is on the bottom. So the answer is 9/10. And there's nothing more I can do here to simplify. There's nothing I can divide by that's going to make that any simpler. So what if I had 9/11 divided by 7/8? Well, that's just going to be 9/11 divided by 7/8. In order to change the problem to multiplication, I just write 9/11 times, and over here, 8/7. I take this over and I flip it over like this. Now, 8 times 9 here is 72, and 11 times 7 is 77. So 72/77. We have one last problem here, which is going to be 4/5 divided by 5/6. Okay, so what I'm going to have here is 4/5 multiplied by, and I'm going to take the second fraction, flip it over, it's going to be 6/5. And then at this point I just do it like multiplication. 6 times 4 gives me 24, and 5 times 5 gives you 25. So the answer is 24/25, and there's nothing more I can really do to simplify that anymore. So dividing fractions, we didn't do that many problems here, and that is because dividing fractions really and truly is the same thing as multiplying them. So once you know how to go back and do the multiplication section, which we've already talked about, multiplication becomes really, really easy. You just take the first number that you start with in the problem, and then you change the division to multiplication. You take the second fraction and flip it over, and then you just treat it exactly like a multiplication problem. And that is how you divide fractions. Welcome to this section of the course where we're going to switch gears a little bit. We've been talking a whole lot about fractions, really important stuff. Now we're going to switch gears and we're going to talk about decimal place value. We're going to talk about decimals basically. And then in the follow-on sections we're going to learn how to add and subtract decimals and so on and so forth, okay? But in this section I don't want to do any of that. I just want to talk to you about what a decimal is, okay? So imagine in front of you here you have the number 6 over here and you have the number 7 over here. Well, that's number 6 and that's number 7, but what is between those two numbers, between 6 and 7, okay? Well, you're going to have 6.5 maybe, okay? So when you would ask yourself the question, what is between 6 and 7, okay? Well, you might have, for instance, 6.5. That just means you're 6 and then you have a half more, because don't forget, fractions are used to talk about things in between numbers, okay? So 6.5, 6 3/4, 6 1/4. There's a lot of fractions in there, okay? But fractions are kind of a pain to write down. I mean, they have a bar and there's the two numbers. So we have something else that we can use to talk about numbers when they're between the whole numbers there, and that's called decimals, okay? So anytime you have a decimal point, okay, you have some part of the number that's just kind of between two big numbers, between two whole numbers, okay? So to kind of see that, let's talk about what we're going to call the number line. Let's say this is the number 6, okay? This is the number 6, and over here, we're going to say this is the number 7, okay? So we're going to have this thing, we're going to call it the number line, okay? Here's the number 6, and way over here's number 7, and then way over there's number 8, number 9, number 10, and then over here, way back over here is 5, 4, 3, okay? But here we're only going to be looking at what is between 6 and 7. Now, we already said that between 6 and 7, we're going to have 6.5, right? 6.5, and it's going to be right in the middle here, okay? So let's go ahead and do that. We'll look here. We'll have 6.5, but we're going to write it a little bit differently. Instead of writing the 1/2, we're going to say 6.5, okay? 6.5. Now, to understand where this comes from, here is 6.1, 6.2, 6.3, and 6.4. So let's write this down. This is 6.1, 6.2, 6.3, 6.4. And then here's 6.5, okay? So what would come after 6.5? You'd have 6.6, 6.7, 6.8, 6.9, and then 6.10, which is basically just going to roll over. It's not going to be 6.10, it's just going to be 7, okay? So let's continue on here. You'd have 6.6, 6.7, 6.8, 6.9, and then you get to 7. Here we have a bunch of decimals, okay? Basically all it means is anytime you have a number with this decimal point and then a number after it, it's just trying to tell you some fraction of the number between, between this number and the next number. So all of these numbers, 6.123, 1, 2.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9. All of those are little tiny numbers in between the big numbers, which is 6 and 7. That's really all it means, okay? So if I were to tell you, go give me, or go, 6.2 of something, well, you're going to know that 6.2 is pretty close to 6. It's not too close to 7. It's kind of over here. 6.5 is going to be right in the middle. Okay, 1, 2, 3, 4, 5, and that's kind of why it's 6.5, and so on. So you're going to have that. Okay, so when we're talking about stuff like this, okay, let's take the number 6.3 for instance. Okay, this first digit behind the decimal point is called the tenths place. Okay, it's called the tenths place. Okay. It's called the tenths place. And then as you go more and more decimal points beyond there, you'll have different placeholders that we'll talk about in just a minute here, okay? So these are the numbers between 6 and 7. Now, I'm going to blow your mind a little bit here, and let's talk about something very cool, okay? Let's look at the numbers only between 6.3 and 6.4, okay? So let's do that over here. Here I'm going to come out right here, okay? So now over here, actually what I'm going to do is I'm going to draw it right under here. Here's 6.3, and then way over here on the right, just like before, here's 6.4. And again, I'm going to have another number line. And this number line, this entire number line is representing everything just between 6.3 and 6.4, okay? So here in the middle, you're going to have something kind of in the middle of 6.3 and 6.4. What you're going to have is, you're going to have 6.35, okay, 6.35. So over here, 1, 2, 3, 4, what you're going to have over here, you're going to have, let me go ahead and write this a little bit smaller, make it a little bit simpler to understand, okay? Here's the 6.3, okay? Down here, you're going to have 6.31, 6.32, 6.33, 6.34. Here's 6.35, and then 1, 2, 3, 4, 5. We'll have 6.36, 6.37, 6.38, 6.39, and then when we get to the end, again, we get to 6.4, okay? So no matter how deeper and deeper and deeper you go into looking at the numbers, you can add more and more and more digits behind this decimal point, and all it's doing is it's more accurately telling you what number you're actually at, okay? So you can keep doing this again and again and again if you want. You could look at all the numbers between here and make another number line, and you can do it again and again, okay? But there's no point in doing all that, okay? I just want to kind of tell you what the big deal is here. So if you had a number like 6.37, remember this first digit is called the tenths place. Well, this second digit is called the hundredths place, okay? And then if you had something like 6.377, if you added another digit here, then this last digit would be called the thousandths place, and so on, okay? So the bottom line is, behind every number you can add a decimal point, and you can start adding numbers back there. Now, the numbers behind the decimal point are just trying to zero in on exactly where you are between the number here and between the next whole number. So anything behind a decimal point is kind of like a fraction. It's telling you how close are you to the next number. Obviously, the bigger the number behind the decimal point, the closer you are to the next number. So here we were at 6.3. That's not too close. If we were at 6.9, we'd be pretty close. We'd be closer to 7 than we were to 6. So putting digits after the decimal point is just trying to tell you how close you are to the next number. Now you can keep adding digits here, okay? Here we added 1, here we had the hundredths place, here we added 1, and we had the thousandths place. The only other thing I really wanted to tell you is that when you start adding digits behind a decimal point, okay, the digit right after the decimal point, the tenths place, is worth more than the next digit, which is called the hundredths place, and this one's worth more than the thousandths place. And that can be seen right here on the board here, okay? The very digit right after the decimal point is going to determine where I'm at, pretty close, pretty close. Am I going to be close over to the 6 or am I going to be closer to the 7? As I start piling digits on, it's going to more accurately define where I'm at. You notice the second digit here, the second digit only affected where I'm going to be between 6.3 and 6.4. So it's only going to be able to do that for me. So the more digits you add after a decimal point, it doesn't mean the number gets bigger. I mean, you can have 7.7696342891011, and that isn't going to mean that that's a huge number. All it means is that you're really, really accurately saying after the decimal point what your position is between 6 and 7, okay? But the digit right after carries the most weight, followed by the next digit and the next digit. And that's really all I want to say about this section. Just remember that a decimal is kind of like a fraction. It's just telling you when you're in between numbers where exactly you are, okay? And it's used to kind of tell you that. And you can continue adding digits behind the decimal, and that'll kind of more accurately tell you where you are between numbers, okay? And when we get to multiplying and dividing and adding and subtracting decimals, we're going to have to think about what we want to do with the decimal point, okay? So that is a basic introduction to decimal place value. Hi, and welcome to this section of the tutor where we're going to talk about adding, subtracting, and multiplying decimals. In the last section, we've introduced what decimal place value is. And in this section of the course, we're going to talk about how do you add numbers that have decimals, how do you subtract them, how do you multiply them, and then we're going to save division for another lesson, okay? So let's go in and let's say, what would you say if you had a problem like 7.6, that's a decimal, plus 8.2, okay? 7 plus 6 plus 8.2. Well, the good news is adding, subtracting, and multiplying decimals are very, very similar to what we've already done in adding and subtracting and multiplying numbers. So there's not going to be that many examples here because it's going to be almost exactly the same thing. I'm just going to teach you a couple of rules along the way. You're going to do the same thing you always do. You're going to line these things up on top of each other. And you're going to go ahead and keep your decimal points here as well. What you want to do, okay, is you want to line these decimal points up one on top of each other. Okay, so you're going to write the numbers on top of each other, you're going to line your decimals up, okay? And then after that, you're going to basically add just like you always add. So that's why I say it's going to be almost exactly the same. So we're going to start in the right-hand column like we always do. 6 plus 2 is going to give you 8, right? And 8 plus 7 is going to give you 15. So you put 15, okay? So you have 8 and you have this 15. Now, the only thing you have to realize with decimals is when you add them, you line the decimal up, and all you do is you take that decimal and you drag it right down, okay? So the answer is 15.8. So literally, it is exactly the same thing as what you've done before. You add your numbers, and then when you're done, you take that decimal point that you have in your problem, which you've lined up, and you just pop it down there. Nothing special, nothing hard, okay? What if you had something like 18.2 plus 9.8. So again, you say 18.2, 9.8. You line your decimals up and you put your numbers one on top of the other. And then you go ahead and add just like you would always add, okay? 8 plus 2 gives you 10, but 10 is too big of a number to write down here because I have other values here, so I'm going to put the 1 up in the next column up on the top, just like before. Nothing is different, nothing has changed, okay? 8 plus 1 is going to give me 9, plus another 9 is going to give me 18. So I put an 8 down there, and again I need to carry my 1 over to the next column, okay? Like this. And then finally, 1 plus 1 gives me 2, okay? And the final thing is, whenever you finish a problem, you take your decimals that you've lined up and you drag it down and you put it right between there. So this literally is exactly the same methodology, exactly the same steps as in the previous section when we started adding numbers. Start in the right column, carry as you need to. Here we had 1 plus 8 plus 9 gave us 18. We had to carry a 1, and then we write our final number down. And when we're done, we take the decimal and we pop it down there, and we don't do anything differently. So 28.0 is going to be the answer, okay? Just going to do a couple more here with addition and subtraction because it really is so similar. What if you have 13.4 minus 11.2? So you're going to do the same thing that you always do. You're going to write the big number on the top and the smaller number underneath it, and you're going to line these decimal points up one underneath the other, okay? And then you're going to subtract. Start in the right column. 4 minus 2 is going to give me 2. 3 minus 1 is going to give me 2. And 1 minus 1 gives you 0, but you don't need to write that because that's a leading 0 here. You never have to write those down. And then you just take your decimals, which are right here, and you drag it down. You put one right between these two numbers. 2.2 is the answer. And when you think about it, this kind of makes sense because it's 13.4, which is somewhere around 13, and 11.2, which is somewhere around 11. So you know that 13 minus 11 is 2, so the answer is going to be somewhere around 2, and it turns out the answer is 2.2, which is just a little bit more than 2, okay? So it kind of makes sense, okay? The last addition and subtraction problem I'm going to do is going to be, what if you had 29.5 minus 3.1, okay? And so you would write, just like always, the bigger number on the top, 29.5 on the top, and then 3.1 on the bottom, and you're going to subtract them. And you line these decimals up. That's what you do, okay? Start in the right column. 5 minus 1 gives me 4. 9 minus 3 is going to give you 6. And 2 minus 0 is going to give you 2. And just like before, you take this decimal point, you drag it down, and you put it in between. So you have 29.5 minus 3.1 gives you 26.4, and you just take that decimal point, you drag it down, and that makes a lot of sense because you started with 29 and 0.5, which is roughly 29, and you have 3.1 you're subtracting off, so you know that 29 minus 3 is going to be around 26 or so, okay? Now you've got these decimals here, and so it's not quite exactly equal to 26, it's 26.4, so the answer kind of makes sense, okay? Now, the next thing we're going to do is we're going to multiply decimals. We've done adding and subtracting. We've only done a few problems because adding and subtracting decimals really is exactly the same as what you already know. Okay? You just have to line those decimals up and drag it down into your final answer. Now we're going to go ahead and do a couple of multiplication problems, which are going to be almost just as easy. Okay? We're going to do a couple problems. It's almost exactly what you already know. It's pretty easy. So what if you had a problem like 3.2 times 2.4, and you're going to multiply those together? Well, you just write the problem the same way that you usually do. 3.2 and 2.4, and you're going to multiply, okay? Now, for now, whenever you go ahead and do this, just like in the addition and subtraction problems, just ignore the decimal. Just don't even worry about the decimal until the end of the problem, okay? So let's do that. How would we multiply if these decimals weren't here at all? Okay, we've done tons of problems like that. You would say 4 times 2 is going to give you 8, okay? 3 times 4 is going to give you 12, and we're going to move over to this digit, so we're going to have to put a 0 here. 2 times 2 is going to give us 4, and 2 times 3 is going to give us 6, okay? So we've done all the multiplication the same way that we would have done it before, which we've done lots of problems in the past sections. Now we're going to add these up. 8 plus 0 is going to give us 8. 2 plus 4 is going to give us 6, and 1 plus 6 is going to give us 7. Okay? So we've done the problem exactly as we usually do. We haven't even looked at the decimals. Now here's the only difference between what you know and what the decimals do, and what the decimals bring to the table. All you do when you're done doing the multiplication is you look in the original problem and you count how many digits after the decimals do you have. Here's 1. Here's 2, okay? If this had another number here, it would be 1, 2, 3, okay? If this one had, something like this, it'd be 1, 2, 3, 4, 5, okay? But none of those are there, so we don't have to worry about that. So we have 1, 2, okay? 2 decimals. So then you start at the right of your answer and you go left. 1, 2, and you put your decimal here. 7.68 is the answer, okay? 7.68 is the answer. So notice it's a little bit different. When you add and subtract, you line the decimals up and then you just drag the decimal down. Here, you do the multiplication exactly as you usually do, but then you count the decimals up behind the decimal point and you move left this many times from the right. 1, 2, 7.68 is the answer. Okay, we're going to do one more problem to multiply decimals, and that's just because they're very, very similar to what you already know. What if you had 4.25 times 5.1? Okay, 2 decimals multiplied together. How would you do that? Well, you go ahead and write 4.25 on the top, and then you can go ahead and write 5.1 on the bottom. Now notice it's not needed, it's not necessary to line the decimals up when you're multiplying them. You can just kind of write them over, you can line the numbers up, and you can just kind of put your decimal. You don't need to line them up because you're not going to drag that decimal down to the bottom like you do when you add them and subtract them, okay? So let's go ahead and multiply and see where it takes us. 5 times 1 times 5 is going to be 5. 1 times 2 is going to be 2. 1 times 4 is going to give me 4. So far not too bad. Let's move to the other column. And because I'm going to do that, I'm going to put a 0 here. 5 times 5 is 25. So 25 is too big to write down, so I'm just going to put a 5, and I'm going to carry my 2 up to the top of the other column. Now, 5 times 2 is 10, but you're going to add 2 more, which is going to give you 12. So I'm going to put a 2 here and carry my 1 again up here, because I have to write 5 times 2 is 10 plus 2 is 12. So I put the 2 and I carry the 1. Now 5 times 4 gives me 20, but I got to add my 1, so that's going to give me 21. So I do the multiplication exactly as if there's no decimals here anywhere, okay? Now I just add up. 5 plus 0 gives me 5. 2 plus 5 gives me 7. 4 plus 2 gives me 6. 1 plus 0 gives me 1. 2 plus 0 gives me 2. Okay? So I have 2, 1, 6, 7, 5 on the bottom. And then I haven't done anything with the decimals yet. But just like before, all you have to do is count how many digits total in your problem do you have. 1, 2, 3. Okay? Here's 2 from this number and 1 over here. If you had some more digits out here, you'd have to count them up. 1, 2, 3. So then you just start at the right-hand side and go left 3 places. 1, 2, 3. So then you put your decimal point there, and the answer that you're going to get is 21.675. Okay? So when you're multiplying decimals, it's really easy. You just write the problem down and just forget the decimals are even there. Multiply just like you always do, okay? And then when you get your final answer, count the number of decimal places you have in the problem and just move left that many places. Put your decimal down, and then that will be your answer. Hi, and welcome to this section of the tutor where we're going to tackle the problem that gives a lot of people difficulty, and that is how to divide decimals, okay? We've already learned how to divide using long division back in the earlier part of the class here, okay? So if you don't know how to do that, definitely need to go back and learn that now, because this is going to be a little bit more challenging. But in the end, if you know how to do that, as far as doing the long division that we talked about in the first parts of the class, then dividing decimals really isn't going to be that hard. So let's go ahead and do a problem, and I'll show you what I'm talking about. What if you have 3.45 divided by 2? And you want to divide this guy, okay? Well, the first thing you do is just like in the other problems. You go ahead and write your 3.45 under the house and your 2 on the outside, because that's what you're going to divide in. And every time you have a division problem, you take this decimal point and you go ahead and you put a decimal right on top of the line. Because in the end, you're going to put numbers here and the decimal point is going to be fixed, okay? You're not going to move that. So you just take your decimal point, you just put it above the line, okay? And the only way you can really describe how to do this is to work a lot of problems, so that's what we're going to do, okay? Just like before, you say, how many times can 2 go into 3? The answer is 1 time, because 1 times 2 is 2. And 2 times 2 would be 4, and that's too many times. So it can only go one time. So we multiply, and 1 times 2 is 2. And we draw our line, okay? Now we do some subtraction like we always do. 3 minus 2 is going to give us 1, okay? And you ask yourself, can 2 go into 1, okay? The answer is no, it really can't. But before we give up, we're going to take this 4 and we're going to drop it down and make it a 14. And this is all exactly the same as what we've done when we divided numbers in the beginning of this class. So go back there if you don't quite understand this. We're going to drop this 4 down. Now the next question we ask is, can 2 go into 14? Okay? The answer is yes, it can go 7 times. Why? Because 7 times 2 is 14. Okay? So you multiply and you write that down, and you subtract, and you're going to get a 0, because 14 minus 14 is 0. Can 2 go into 0? Well, no, of course it can't, but before we give up, we're going to drop down this 5. Okay? We're allowed to drop down one number from the next column anytime you can't divide what you have here. Okay? We ask ourselves, can 2 be divided into 5? The answer is yes, it can go 2 times, because 2 times 2 gives us 4. Okay? Because 2 times 2 gives us 4. And we subtract, like always. 5 minus 4 gives you 1. Now here's where the decimal stuff starts to get a little bit tricky. The next thing we do is we try, will 2 be divided into 1? Well, the answer is no, you can't do that, okay? But in decimals, there's no more digits over here that you can see that you can drop down to help yourself. But in decimals, you're allowed to add a 0. In fact, you're allowed to add as many zeros as you need. So what we're going to do is we're going to add a 0 up there, and we're going to drop that 0 down and make him a 10. Okay? And we ask ourselves, can 2 be divided into 10? The answer is yes, it can go 5 times. 5 times 2 gives you 10, okay? And 10 minus 10 gives you 0. And since you have nothing else left down here, okay, and you have no more digits up here and nothing more to drag down, you're done. You've filled out as many digits as you can. The answer is going to be 1.725, okay? Now this is quite a bit different than what we used to do when we were dividing regular numbers. Regular numbers, when you would divide down, you could get down to a point here and you couldn't divide anymore, you had what we call a remainder, okay, and you kind of wrote that remainder down in your answer. In these kinds of problems, you're never going to have a remainder, okay? You're going to be able to divide down and down and down, and you're allowed to add digits over here and drag them down until you get a remainder of 0, or, and we'll see in another problem, you start to see some repeating pattern up here in your decimals. So if you ever got to the point where it was 1.725, 725, 725, 725, 725, we'll see some problems in a little bit, and you'll see what I'm talking about down here. But when you start getting into some repetition, then you can just stop, okay? But you're allowed to add digits to keep helping yourself out over here until you either get 0, which means basically when you have all your digits lined up here, you can't do any more dividing, okay? Or you see a repeating pattern, okay? Long division with decimals is probably the most difficult thing in elementary math, and so we're just going to work through some more problems, and I think you'll get the hang of it. 2.25 divided by 2, okay? How do we do that? We write 2.25 underneath the house, okay? And we put 2 on the outside of the house. And then the next thing you do is you put your decimal point right above here, okay? Now you just tackle it like any other division problem. 2 divided by, goes into 2 times, goes into 2 one time. 1 times 2 gives you 2, okay, and then you just do your subtraction. 2 minus 2 gives you 0. Can 2 go into 0? Well, no it can't, but I have another digit I can drag down, and that's going to be a 2. How many times can 2 go into 2? Again, it can only go one time. 1 times 2 gives you 2. 2 minus 2 gives you 0. Okay, so you multiply and then you subtract. Can 2 go into 0? Well, of course it can, but you can drag down your next digit, which is a 5. Can 2 go into 5? Sure, it can go 2 times. 2 times 2 gives you 4, okay? And 5 minus 4 gives you 1. Can 2 go into 1? Well, no it can't, and I don't have any digits left to drag down, but in decimals, I'm allowed to add zeros to the right of the decimal point, and I'm going to add this 0 down and make him a 10, okay? Now I can do this. 2 divided into 10 goes 5 times. 2 times 5 gives you 10, and you're going to be left with 0. So there's nothing else here. There's no more digits to drag down. You were done. 1.125. Okay? So basically you keep dividing and dividing and dividing, and if you ever continue to get a number down there, you can invent a 0 and drag it down. As long as you've got a decimal point here, you can do that. Okay? Okay. What if you have 5.5 divided by 5? Okay? What you would do is you would write 5.5 and you would put a 5 out here. Then you would take your decimal point and you would write it up above there, because that never moves. And then you would try to divide. 5 can go into 5 one time, okay? Because 1 times 5 gives me 5. And now I can subtract 5 minus 5 gives me 0. Can 5 go into 0? Well, no, it can't, okay? But I can drag down my next digit, which is a 5. Can 5 go into 5? Yes, it can, one time. 1 times 5 gives me 5. Subtract, like always. 5 minus 5 gives me a 0. Now there's nothing left here, okay? I've got all my digits filled out and there's no more digits here. There's no reason to add another 0 because I've already filled in all my digits and I've got a 0 left over there. So the answer here is 1.1. And so just like always, if you're going to check your answer, all you have to do is take 1.1 and multiply by 5. This times this should give you this. 5 times 1 would give you 5. 5 times 1 would give you 5. And for the decimal, you've only got one digit behind the decimal, so you move left one place, and then the answer would be 5.5. Okay? So it's very similar to the division you already know. Okay, you just got to keep track of these decimals. What if you had 10.75 divided by 2? Okay? You would write 10.75 divided by 2, and you would write your decimal point for your answer right above there. And then you just try like usual. Can 5 go into 10? Yes, it can, 5 times. 5 times 2 gives you 10. And then you go ahead and subtract, okay? You're going to get a 0 here, and you say, well, can 2 go into 0? No, it can't. But I go ahead and I drag my 7 down, okay? Notice I'm not doing anything with the decimal under here. Can 2 go into 7? Yes, it can. 3 times, because 3 times 2 is going to give me 6. And again, I can subtract. And I bring a 1 down. Can 2 go into 1? Well, no, it can't. But before I give up, let me go ahead and drag down my next digit, which is a 5. Now I ask, can 2 go into 15? Yes, it can. The closest I can get is 7, because 7 times 2 is 14. Okay? 7 times 2 is 14. And when I take 15, subtract 14, I'm only going to have 1 left over. Question is, can 2 go into 1? Well, no, it can't, but don't forget that in decimals, you're going to have to start adding zeros. Basically, you're always going to have a remainder of 0. So let's drag a 0 down. Can 2 go into 10? Yes, it can. 5 times. 5 times 2 gives me 10. 10 minus 10 gives me 0. So now I have a 0 down here finally, okay? And no more digits to drag down, so I'm done. I stop. 5.375. I know that this is coming fast and furious, but the only way that you can really get good at these is to do a lot of these problems. It's really the only way. What if you have 10.75 divided by 3? Okay? Well, you write 10.75, you're dividing by 3, and you put your decimal up there because that's where your answer is going to be. How many times can 3 go into 10? Well, it can go 3 times, because 3 times 3 is just going to give you 9, and 9 is as close to 10 as I can get. Now 10 minus 9 is just going to give me the 1, so I write that down. Can 3 go into 1? No, it can't, but before I give up, drag down my next digit, make it a 17. Can 3 go into 17? The closest I'm going to be able to get is 5, because 5 times 3 is 15. Okay, and then again I subtract. 7 minus 5 gives me 2. 1 minus 1 is 0, so I don't have to write that. So 17 minus 15 gives me 2. So the answer is, the question is, can I take 3 and divide it into 2? Well, no, I can't. So I try before I do anything else and drag another digit down. Can 3 go into 25? Can 3 go into 25? Yes, it can. It can go 8 times because 8 times 3 is 24. Okay? 8 times 3 is 24. 25 minus 24 is just going to give me 1. Can 3 go into 1? Well, no, it can't, but I can, remember, add a 0 anytime I need to. Let me try to drag that 0 down and see what happens. And now, here's where the problem starts to get tricky. 3 divided into 10 goes how many times? Well, 3 times 3 gives me 9. That's as close as I can get. 3 times 3 gives me 9. So I write that down. And I subtract, and I get a 1 here. Okay? I get a 1 here. Well, can 3 go into 1? Well, no, it can't. Well, I can add another 0 if I want. And I drag it down and make a 0. And I have 10 again. How many times can 3 go into 10? Well, it can only go 3. Okay? And so 3 times 3 gives me 9. 10 minus 9 gives me 1. You see, I'm in an infinite thing here. I can never get out of this problem here. Okay? You see, every time I add a 0 and drag it down, I'm going to have 10, like I had right here. And every time I try to divide it into 10, I'm going to have to put a 3 up here because 3 times 3 gives me 9. But every time I do that, I'm going to subtract, I'm going to get 1, and that's going to be exactly where I start with. You see, it happened here, and then it happened here, and it's going to happen again if I keep adding zeros. So you can keep adding zeros all you want. You're never going to get anywhere. Okay? So you can see I keep putting 3's up here because that's exactly what the answer is going to be because of this problem with the 10's down here. So the answer to this problem is going to be 3.5833333. It goes on. The 3's go out forever and ever and ever and ever and ever. Okay? And another way to write that is 3.583, and you can put a little bar over the 3, and that tells you that the 3 goes on forever. The 5.8 doesn't go on forever, but the 3 goes on forever. So now I can say with a little more confidence to you, now that you've seen a problem, that when you're dividing decimals, you keep going until you get a 0 here with no more digits to drop, or if you ever get caught into one of these loops where you keep adding digits because you keep getting the same thing over and over and over down here, then there's no point to continue. You just stop and say, okay, well, the answer is going to have a repeating number of 3's. Okay? Now, if you were to take this in your calculator, 10.75, and divide by 3, you would see that the 3's would go on and on and on forever. Okay? So just keep dividing and keep doing the rules that you know until you run into something that repeats or until the answer cleans itself up and is nice and neat. Let's try 7.25 divided by 3. Okay? So you have 7.25 divided by 3, and I'm going to put a decimal up there. Okay? How many times will 3 go into 7? Well, only twice because 2 times 3 is 6. So I subtract and I put a 1 down here. Okay, can 3 go into 1? Well, no, it can't. So I drag the 2 down. Now I have 12. Can 3 go into 12? Well, sure it can. It can go 4 times because 3 times 4 gives me 12. Now I subtract. 12 minus 12 gives me 0. Okay, can 3 go into 0? Well, no, it can't. But let me go ahead and try to drag my 5 down here and see what this does for me. Okay, 3 divided into 5 can go only 2 times because, actually, 3 into 5 can only go 1 time. 3 times 1 gives me 3. Okay, and 5 minus 3 gives me 2. Okay, now the question is, can 3 go into 2? Well, no, it can't. So what I'm allowed to do with decimals is add a 0 and drag it down here. You can't do this unless it's a decimal, okay? So I make it a 20, okay? 3 goes into 20. How many times will 3 go into 20? I'm going to say it goes 6 times because 6 times 3 is 18, okay? And in order to subtract this, I borrow the 1, make this a 1 here, so I have to borrow. And then 10 minus 8 is going to give me a 2, okay? Is going to give me a 2. Can 3 go into 2? Well, no, it can't, so I add another 0. I drag it down, put a 0. Well, here I had a 20 here, now I have another 20. 3 goes into 20, again, 6 times because 6 times 3 is 18, and the same thing is going to happen. I'm going to have 2 left over. I'm getting into another one of these repeating patterns. And every time it happens, I'm going to add another 6 and another 6 and another 6, on out and on out. Here I had 20, and then I did it, and then I had another 20, and then I did it again, and I'm going to have another 20 eventually whenever I drag the 0 down. So the answer is 2.416 with a bar over the 6, and that just means that the 6's go on and on forever. It just means that the 6's go on and on forever. So this is what we mean when we say there's, keep going until you have a repeating pattern, or keep going until, your answer basically cleans itself up. What if you have 6.75 divided by 0.3? Okay? So you'd have 6.75 divided by 0.3. Well, you put your decimal point up above here. Now, look at what we have here. You have a number, a decimal, and you're dividing by another decimal. This is a little bit different kind of problem because you have a decimal divided by a decimal. But it turns out it's really, really simple, okay? In order to do this, all you do is you move this decimal point over 1 and this decimal point to the same amount over, okay? So when you rewrite your problem is going to be, when you move the 3 over there, it's going to be a 3. And then you're going to have 67.5 on the inside. And you're going to have your decimal point over here for the answer, okay? What you have done is you have transformed the problem into something you like. You always want to divide by a number that doesn't have a decimal point. So we move this decimal point one place to the right, and 3.0 is just going to be 3, so I can just write the 3 here. And I also have to do the same thing here. I have to move the decimal point the same number of places in each part of the problem. So I made it 67.5. And now I can go ahead and do my division. Okay, how many times will 3 go into 6? Let it go 2 times. 3 times 2 gives me 6, so I subtract. I'm going to get a 0. Can 3 go into 0? Well, no, it can't, so I drag my 7 down. Can 3 go into 7? Yes, it can. 2 times. 2 times 3 gives me 6. Okay? And again, I subtract and I get a 1. Okay? Can 3 go into 1? Well, no, it can't, but let me drag my next thing down, which is a 5. And then finally, can 3 go into 15? Yes, it can go 5 times because 3 times 5 gives me 15. And when I subtract these, I get 0. I've got a 0 here. I've got no more digits here to drag down, and I've got all my digits filled out here. So the answer to this problem is 22.5. The only thing you have to do if you're dividing by a decimal is move the decimal point over enough places so you get rid of the decimal point, and you have to do the same thing underneath the division symbol. It's kind of like the fractions. As long as you do this, move the same number of decimal places in each place, then you're not going to have any problems. So working with another problem, what if you had 21.35 divided by 0.7? Okay? So that's 21.35 divided by 0.7. Now notice I'm dividing by a decimal, and I don't want that, so I'm going to move this decimal over 1, and I'm going to move this decimal over 1. So what I'm going to have is 213.5 on the inside, and I move this decimal point over to the 1, so I've got a decimal point to the right here, and you don't have to write that down because 7.0 is just 7, okay? And then you do the same thing to the inside, 213.5, so you move it over 1. You write your decimal point right above here like this, and then you ask yourself, can 7 go into 2? Well, no, it can't, so let's try both digits. Can 7 go into 21? Yes, it can go 3 times. 7 times 3 is 21. Okay? You subtract this, you get a 0. Okay? Can 7 go into 0? No, it can't, so you drag your 3 down. Can 7 go into 3? Well, since you already dragged your number down, okay, and now you're trying to ask yourself, can 7 go into 3? Well, no, it can't. It can go 0 times, okay? Once you drag that next digit down, if you still can't divide into it, you have to put a 0 somewhere. You have to have digits everywhere here, okay? 0 times 7 gives me 0, so I just subtract. 3 minus 0 gives me 3. And can 7 go into 3? Well, no, it can't, but before I give up, let me go ahead and drag my 5 down. Now, can 7 go into 35? Well, yes, it can, because 7 times 5 gives me 35. 7 times 5 gives me 35. Subtract. I get 0. 35 minus 35 is 0. And there's nothing left to do. I got a 0 down here. I've got all my digits filled out here. I don't have anything else to drag down. So 213.5 divided by 7 is 30.5. Now, the last thing that I really want to talk to you about is a little bit about the relationship between fractions and decimals, okay? Any fraction can be written as a decimal, okay? Let me show you what I mean by that. Remember, fractions are numbers less than 1. So let's say you have the fraction 1/3, okay? And we already talked about in terms of pies, okay? You know, that's one, if you divide this pie into 3 pieces, 1/3 of that would be what you have. That's not the best drawing, but if you divide your pie into 3 pieces, 1 piece is going to be what you have there. How would you write that as a decimal? Okay? Well, it's 1 divided by 3. That's what a fraction means. That's what this bar really means. Notice the symbol for division is this. That's kind of like a fraction, right? 1 divided by 3. So what you have is 1 underneath the house divided by 3. Okay? Now, it may not be clear what to do, but never forget that anytime you have a number, you can put a decimal and you can put some zeros over here. 1.00 is the same thing as 1. 1.000000 is the same thing as 1. You can put any number of zeros behind a decimal point, it doesn't matter. So let's go ahead and do this division and let's see what would happen. Okay? Can 3 go into 1? Okay? No, it can't, so I'll put a 0 up here. Okay? 0 times 3 gives me 0. 1 minus 0, just the same as always, is going to give you 1. Can 3 go into 1? Well, no, it can't, but before I give up, let me drag down my 0. Okay, I'm going to have 10. Can 3 go into 10? Well, sure it can. And you put your decimal point up above just like you always do. 3 goes into 10 3 times. Okay? 3 times 3 gives you 9. Okay? 10 minus 9 gives me 1. Okay, just like I always do. Can 3 go into 1? Well, no, it can't. But let me go ahead and drag down my 0. Okay, like I always do. Can 3 go into 10? Yes, it can. 3 times. You see, I'm in one of these repeating patterns because every time I do this, I'm going to put a 9 down here and subtract, and I'm going to get a 1. I'm going to have to drag another 0. Here was 10, here was 10, here I'm working on doing another 10. The same thing's going to happen, so I'm going to put a bunch of 3s up here. So 1/3 is exactly equal to 0.3333333, and the bar just means 3 repeats over and over again. Okay? So that's an example of how you have a fraction, which is a number less than 1. Here is a decimal, which is also a number less than 1. They're exactly the same thing. They're just 2 different ways of writing the same thing. And that's why sometimes fractions are useful, and that's why sometimes decimals are useful. Let's try one more. What if I had 1/4? How would I write that as a decimal? Okay. Well, I have 1, and I'm dividing by 4. And I'm going to go ahead and put a couple zeros here. I'm dividing by 4. Can 4 go into 1? No, it can't, so I'll put a 0. 0 times 4 gives me 0. And I subtract. 1 minus 0 gives me 1. Okay? Can 4 go into 1? No, it can't, so I drag down a 0. Can 4 go into 10? Only 2 times. Okay, only 2 times because 4 times 2 is 8. 10 minus 8 you can do on your fingers. 10 minus 8 is going to give you 2. Okay? Can 4 go into 2? Well, no, it can't, so I have to drag another 0 down. Can 4 go into 20? Yes, it can, 5 times. 5 times 4, go ahead and multiply, gives you 20. And when you subtract, you're just going to get 0 here. So there's no more things to do here. You have a 0, you have all your things filled out here, and you fully divided everything out. So 1/4 is equal to 0.25. That is the decimal equivalent of this fraction that we call 1/4. 2 different ways of writing the same thing. And any number of fractions, any fraction, you could do this way, and you could find the decimal equivalent to it. And that's what you do if you ever get a calculator out and you have to multiply by some kind of fraction. If you were to take 1 and divide by 4 in your calculator, you would see that the answer is 0.25. That's how you work with these things with computers and with a calculator, and a lot of problems you need to know how to do that. Hi, and welcome to this section of the tutor where we're going to switch gears and we're going to talk about another topic that's really, really important, and that's the topic of percents. You probably heard about percents. Somebody says on the weather, on the TV or something like that on the news, like there's a 40% chance of rain tomorrow, or there's a 10% chance of rain tomorrow, or there's a 100% chance of rain tomorrow, something like that. And that's something that's all around us, and it's something that's important for us to know. So the question is, what is a percent? What does it mean when we say that there's a 50% chance of rain tomorrow, okay? The thing to remember is the word percent means per 100. Cent is kind of a French word. It means 100. So percent means something compared to 100. That's kind of what it means. So when someone says 50% or 60% or 30% or 10% or something like this, all they're doing is they're taking a number and they're comparing it to 100. And that kind of gives you a feeling for you know, how close something is to 100. It's a useful comparison to make. So let's go ahead and figure out by doing some work on the board what percent really is and what it means to us. Okay, so the thing to remember is percent, okay, percent, that's how you say percent, is just simply comparing a number to 100, to the number 100. That's all it means, okay? So to take an example of that, somebody might say 10% or something like this. So they would write 10 and then put this little symbol over here, and that means percent, 10%, okay? Now the question is, what does it mean, okay? Now what I told you already is that percent is comparing a number to 100. So when you write down 10%, all you're doing is you're saying 10 compared with 100, okay? So what we're going to do is we're going to write that down in a way that we're going to be able to see what we're talking about. So I'm going to write the 10 down here, okay? And I'm going to write 100 down underneath it, okay? So I'm going to write a fraction down, okay? Because what we're doing here is anytime you have 10%, what it means is 10 in comparison to 100. So I'm just going to write the 10 on the top and the 100 on the bottom because those are the two numbers that I'm interested in, 10 compared to 100. Now if you just think about it in your head here, 10, the number 10, isn't too close to 100, okay? 10 is pretty far away from 100. 50 is much closer to 100. 75 is even closer to 100. 99 is really, really close to 100. So all you're doing is you have this scale here. Here's 0 and here's 100. And when you express a percent, you're just figuring out where in the middle you are with respect to 100. And we'll see why that's useful here in a minute. But for now, we're going to write this as a fraction, 10 compared to 100. And I'm going to put it as a fraction there. Now, just like with any fraction, you can simplify this fraction. Okay, you can simplify this fraction. This is a fraction that can be simplified. You can divide the top by 10, and you can divide the bottom also by 10. And that'll simplify this fraction. 10 divided by 10 gives you 1, and 100 divided by 10 gives you 10. Okay? So 10%, okay, is the same thing basically as 10 over 100, okay? But I can simplify that to 1 over 10, okay? Now, if you go back and look at the section on dividing decimals or dividing fractions, you could set up a division here, okay? You could say 1, and I can divide 10 into it. This is 1 divided by 10. That's what a fraction is, 1 divided by 10. And I could do this long division, and when you would do that, you would see that this comes out to 0.10 in a decimal form. Okay, I have a lot of stuff on the board here, and it may not make a lot of sense, so I'm going to back up and I'm going to explain everything to you here, okay? 10% is a number compared to 100. It's used to tell us how close we are to 100, okay? And you'll see why later when we work on some problems, okay? So we write this, when we compare it to 100, as 10 over 100. This is a fraction here, okay? We're just comparing it to 100. Now I can simplify this fraction by doing this and dividing by 10 here on the top and the bottom, and I get 1/10, okay? So 10% is the same thing as this fraction 1/10. And I know from my decimals that if I do this long division here, 1 divided by 10, it will be 0.10. Now notice, okay, 10% is equal to 0.10, okay? So all you have to do for a percent, if you want to convert it to a decimal like this, you just take, there's an imaginary decimal point here, you just move it to the left 2 places, 0.10, you just move it to the left 2 places, and you'll get the decimal equivalent of that, okay? So let's take another percent, okay? 25%. This is 25 compared to 100, and it's a bigger percent, so we're closer to 100, okay? So as a fraction, we would write that as 25 over 100 because we're comparing it to 100, right? And this is just a fraction like anything else, so we can simplify fractions, okay? We can divide the top by 25, and we can divide the bottom by 25. because it's just a fraction, okay? So the top is going to be 25 divided by 25, which is 1. The bottom is 100 divided by 25, which is 4. So 25% is the same thing as the fraction 1/4, okay? So remember back from your pie, okay? If I cut the pie in 4 pieces, this is 1/4, okay? This is 1/4 of a pie, okay? Well, what this is saying is 1/4 of a pie is the same thing as 25% of a pie, okay? So really percentages, because you're comparing them to 100, okay, it's just another way of kind of saying a fraction. It's just another way of kind of expressing what a fraction is. 1/4 is equal to 25%, okay? Now, if you were to actually do this division, 1 divided by 4, and do the long division, you would find out that if you wanted to write this as a decimal, it'd be 0.25, okay? Now notice again, to take the percent and convert directly to the decimal, it's real easy. You just take the decimal point here and move it 2 places to the left, and this is your decimal. So some problems may ask you, they may give you a percent, and they may say, what is the fraction that is the same thing as this percent? Well, all you do is you take the percent, you put 100 on the bottom, you simplify it, and then you'll get your fraction. And if they ask you, well, what is the decimal equivalent of this percent? You just move the decimal 2 places to the left, okay? Another example would be 50%, okay? 50%, okay? If you want to convert this to a fraction, you'll just take the 50 and you'll put it over 100, okay? Which is what we always do here. And then this is a fraction just like anything else, so you can simplify this and you could say, okay, I can divide the top by 50 and I can divide the bottom by 50, okay? And I know that that's going to simplify things for me, okay? 50 divided by 50 is 1, and 100 divided by 50 is 2. So what we figured out here is that 50% is exactly the same thing as 1/2, okay? Is exactly the same thing as 1/2. So in this case, what we're saying is that 50% is the very same thing as 1/2, and we did that because what 50% means is 50 compared to 100, or as a fraction, 50 over 100, which reduces to 1/2. So in pie form, in terms of what we were talking about in terms of the pies earlier, here is half of a pie, okay? So half of a pie is 50% of a pie. So now you know what it kind of means when the weatherman says there's a 50% chance of rain tomorrow. What that means is that 50 times out of 100, 50 times out of 100, it'll rain tomorrow, okay? Or about half the time. So it's not an exact science, the weather, you know, they can't exactly predict it with 100% accuracy, but on average, about 50% chance tomorrow. So it may or it may not rain, about 50-50, about half the time it will and half the time it won't. It's just hard exactly to predict. If you had something more like 95% chance of rain tomorrow, then you would know that it's almost guaranteed to rain because 95% is almost very close to 100. And that's what we're comparing to. We're comparing to 100. Okay? So it's just a way to compare, you know, and to kind of give a probability almost. Is what exactly is what a percentage is. It gives you an idea, the certainty in which something will happen. Okay, so just kind of going down the line here, if we had 75%, okay, just to kind of be totally clear here, that would be 75 over 100. That's my fraction, okay, because 75% means 75 over 100. And can I simplify this fraction? Well, sure I can. I can divide the top by 25 and the bottom by 25, okay? And when I do that, 75 divided by 25 is going to give me 3, and 100 divided by 25 is going to give me 4, okay? So 75% is the same thing as 3/4, and if you remember in terms of the pie, that's 3 pieces shaded out of 4, so we're getting closer and closer to filling up the whole pie. So over here, backing up a second over here, 50% is 0.50 and 75% is 0.75. And all you do is you take the decimal and you move it 2 places. So lots of problems may ask you, they may give you a percentage and say, find the decimal. Okay, and all you do is you just move the decimal point 2 points to the left. And that's the answer. It's really simple. And if they want to ask you to convert it to a fraction, you just take the percentage, put it over 100, and simplify the fraction. Now, one more thing that I want to write, I kind of ran out of room here on the bottom, so I'm going to write it up here at the top, is the following. What would 100% be? Okay, 100%. Well, in terms of a fraction, that's 100 over 100, okay? And you already know that 100 over 100, anything divided by itself is 1. So that's the same thing as 1, okay? So what I'm trying to point out here is a percentage. When you increase the number in terms of percent and you get closer and closer to 100, all it means is that the fractional, you're basically comparing it in terms of how close you are to 100. So if you had, 50% of the apples in a basket were rotten, okay, then that would mean, using what we learned here, that about half of the apples are going to be rotten. If you were going to say that 75% of the kids in class were sick with the flu, okay, then that would mean that 75%, which is roughly 3/4, okay, which is a fair amount of the class, it's more than 50%, it's 75%, it's 3/4 of the students have the flu, okay? And if in terms of a decimal, that's 0.75, okay? So it's a really useful way to kind of apply to problems when you have a bunch of people or a bunch of apples or the weather or something like that, and you're trying to express what fraction of those people, are sick or something like this. Instead of just using the fraction, you can use a percentage. And you'll see that a lot in real life. Percentages are used a lot in real life. They're used in the weather. Okay, obviously you've seen that on TV. They're used in your grades. Your grades are a fantastic way to talk about percentages. When you get a perfect score on your test, it's 100%, right? When you get 100 on your test, it's 100%, okay? That means of all the questions on the test, you got them all right. If you got an 85 on the test, it's an okay grade. I mean, it's a B, okay? An 85 is 85% of a perfect score, okay? If you get like a 60 or a 50 on your test, it's a pretty bad grade. A 50% on your test would mean that you got half the questions wrong, okay? So that's what percent means. We're going to work a couple of percent problems that you'll commonly see. If a problem says, convert this fraction to a percent, how would you do that? Convert this fraction to a percent. Well, this is a fraction. You can draw your pie graph, make 10 pieces, and you could shade 2 of those pieces, and that would be true. How would you convert this to percent? The trick is, you need to transform this fraction so that the bottom number is 100, because then, remember in the other problems we had 100 on the bottom, then you will have it in terms of percent. So how can I do that? I can multiply the bottom by 10, which will give me 100, but I got to do the same thing to the top. I can do the same thing to the top and the bottom of the fraction, as long as I do it to both. So on the top, 2 times 10 is 20, and on the bottom, 10 times 10 is 100. Now that I have it in terms of 20 over 100, it's real easy, because anything over 100, you can just write as the top number with a percent sign, 20%. Okay, we just learned that just a minute ago. So that's kind of the common theme in these problems. What if you had 6 over 25? Well, how would you convert this to percent? The easiest way is to multiply the top and the bottom of this fraction by something that will give the bottom number 100. Okay? So the reason I did this was because on the top, 6 times 4 is 24, and 25 times 4 gives me that 100 I'm looking for. So anytime I've got it in terms of something over 100, I just say, okay, I'll take the top number and I put a percent sign. So this is 24%. So what this means is that the fraction 6/25 is the same thing as 24% of something. What if I had 7 over 50? I think you can kind of see the common theme here. You just pick a number that you can multiply by. In this case, it's going to be 2. So after doing this multiplication, on the top, 7 times 2 is 14, and on the bottom, 2 times 50 is 100, which is what I'm after. Okay, and so now that I have it as 14 over 100, you just have 14%. That's the answer here. So if you ever asked a problem on how to convert a fraction to a percent, all you need to do is multiply top and bottom by something so the bottom becomes 100, and then the top number is just going to be your percentage, because what you're doing there is you're converting the fraction and having a denominator of 100. Now what if you had a problem that told you something like, here's 0.7, that's a decimal. convert that to a percent? A lot of times they'll give you a decimal and they'll say, well, what percentage is that? Well, remember when I was telling you earlier, in general, like 75% is just 0.75, and 65%, for instance, was just 0.65. All you do is you take that decimal point here, that implied decimal point, you move it to the left 2 times, and then that's your decimal. Well, that little fact, which is just something you need to remember, is like makes these kinds of problems super easy, because 0.7, if you move the decimal point to the right 2 places, is just going to be 70%. Because if you look at it starting from this end, 70. If you take the decimal point left and then left, you're going to get 0.70, right? And 0.70 is exactly the same thing as 0.7. Remember, you can have trailing zeros after a decimal point as far off as you want, and they don't really add anything to it. So there's kind of an implied 0 right here, and that's why you have 70% there. So it's real easy to take a decimal and make it into a percent. It's almost not even worth writing down the steps. 0.93, okay, how would you convert that to a percentage? Very simple. You just take that decimal and you move it 2 points to the right, so 93%. Okay? It's real easy. Okay? Now what we're going to do is we're going to work a couple of quick problems. I'm going to tell you what the problem is, and then we're going to kind of work it out. And they're going to be sort of like word problems, but not quite so long. You have 10 students in a class. 50% of them have A's. How many students in the class have A's? So there's 10 students in the class, okay? 50% have A's, okay? How many have A's? This is the kind of problem you'll get into a lot, where you'll have a percentage, like 50%, tell you how many students have whatever, and then you'll know how many students. Well, what you do here, okay, it's real easy. You have 10 students in the class, okay? So that's a number we know. The 50%, okay, remember how I told you to write that as a decimal, right? You can take that as a decimal, and you can write that as 0.50, okay, or 0.5 is the same thing. You just take that and you move it twice to the right. And also just remember that it's the same thing as 1/2. We did that before on the other board. We took 50 over 100, simplified that fraction, and get a half. Either way here, okay? So for this problem, I'm going to go ahead and use the fraction, because I'm going to try to give you a flavor for how to do things differently. All you do is you take the 10 people in class and multiply by the fraction of people that have A's. So it's going to be 1/2, okay? 10 times 1/2, okay? Because what we're saying is, since 50% have A's, a half of the students have A's. And this is kind of getting a little bit into word problem territory, but anytime you have so many students in the class, you know, half of them have A's, or anytime you see the word of, almost always you're going to have to multiply, okay? So what you know here is that half of the students have A's, so we're going to multiply by 10. And to do this, we're going to go ahead and put 10 over 1, because we're going to be multiplying fractions. 10 over 1 is equal to 10, okay? Because anything divided by 1 is just itself. So again, to multiply fractions, 10 times 1 is 10, and on the bottom, 1 times 2 is 2. And then this is just a fraction you can divide. 10 divided by 2 will give you 5. So 5 students in the class have A's. Now let's see if that makes sense. We should always do that. 10 students are in the entire class. 50%, which is half of them, have A's. And so it kind of makes sense to you that if half of them have A's, then 5 students must be the 5 that have the A's. Okay? So not that hard. What you need to do in these cases with percentages is multiply by either the fraction, or you can also multiply by the decimal. You'll get the same answer. Okay? So in this next problem, you have 12 pencils. 25% of the pencils have broken lead. How many pencils have broken lead? So again, you have 12 pencils, and 25% have broken lead. Okay? How many have broken lead? Okay? That's what we're trying to find out. So what we're going to end up doing is we're going to take the 12 pencils that we have and multiply by the 25%. Okay? We're going to multiply by the 25%, but we're going to do it a little bit differently. 25% is the same thing as 0.25, and we just learned that before, because you just take that decimal point here, move it 2 points to the right, or you could start here and 2 points to the left. That's how you convert to decimal. And since we started with 12 pencils to begin with, we're just going to multiply by our percentage, which we're going to multiply by the 0.25. Okay? You never multiply by the number in front of the percent here. In other words, 25% is telling you how it compares to 100, but you're never going to multiply by 25, okay? You've got to either convert that to a fraction, which we did in the previous problem, or into a decimal, okay? That's why I taught you how to convert to decimals. So how do we do this multiplication? I've already taught you this. 2 times 5 is 10, so I put a 0, carry the 1. 5 times 1 is 5, plus 1 is 6, okay? Now we're going to move to the next digit, and because we're going to do that, we'll add a 0. 2 times 2 is 4, and 2 times 1 is 2. Okay? So now we add these up. 0 plus 0 is 0. 6 plus 4 is 10, carry the 1. And 2 plus 1 is 3. Okay? And then finally, because it's a decimal, we have to move the decimal point. There are 2 decimal places after the decimal point here. So we start at the right and move left 1, 2. And if any of this is unfamiliar, then go ahead and go back to the section on multiplying decimals. We have 2 digits after the decimal, so move the digit over here. So what we have is 3.00, which is the same thing as 3 pencils that have broken lead, okay? So that kind of makes sense. Let's think about it. You start with 12 pencils. 1/4, which is the same thing as 25%, 1/4. I didn't write that before, that wasn't needed, but you know from the previous board it's 1/4 of the pencils have broken lead. So it kind of makes sense that 3 of them would have broken lead because, you know, it kind of just, I'm getting you to do a little bit of a sanity check here to make sure that it works, okay? 6 is 12 divided by 2. So we know that 1/4 is less than that, and so 3 is right at 1/4. So what you do is you just take the number that you start with and multiply by your percentage, but you got to convert that percentage in order to do it, okay? And this is the kind of stuff this is the kind of reasons why percentages are really useful. You'll find lots of times percentages kind of tell you how many of a certain number of things are behaving in a way. Let's say you have 20 cars in a parking lot, 75% of them are blue. How many cars are blue? So you have 20 cars, 75% are blue. Question is, how many cars are blue? Okay? Well, you want to take the 75 and convert to a decimal. So that's 0.75. Okay? So all you're going to do is you're going to take the 20 cars total in the lot and you're going to multiply by 0.75, like this, okay? Because multiplying by this decimal chops down this total number and tells me how many cars are actually blue, okay? So let's do this. 5 times 0 gives me 0. 2 times 5 gives me 10. Add a 0 here. 7 times 0 gives me 0. 2 times 7 is 14. Let's add these up. 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 1 is 5. And then we'll just drop the 1 down here. And then we have 2 digits after the decimal. So we start here and we go left 1, 2. Put a decimal point here. 15.00 is the same thing as 15 cars in the parking lot are blue. And that makes sense because if 75% of them are blue, that means a majority of them are blue. Okay? And so out of 20 cars, 15 are blue. So the answer kind of makes sense. So again, you just multiply by the percentage. So a couple main things to know in this lesson. A percent is just comparing a number to 100. It's basically kind of a fraction. You take that percentage, you put it over 100, and it is a fraction. You can also convert them to decimals really easily, like I've told you here. You just move that decimal point 2 places, okay? And the reason that they're useful is for problems like this. When you're given a total number of something and a percentage of students or people or whatever it is you're talking about behave in a certain way, well then you can calculate using the percentages just by multiplication exactly how many, in this case, how many cars were blue, etc. It's also very useful for understanding the weatherman on TV, and when they talk about 45% chance of rain, I'm going to be a whole lot more worried if it's a 90% chance of rain than if it's a 20% chance of rain, because 90 is a whole lot closer to 100. And if they ever come out and tell you it's a 100% chance of rain, that means it definitely will rain. No question about it. No question about it. And that is a good introduction to percents. Hi, and welcome to this section of the tutor where we're going to kind of expand on what we learned about in percents, and we're going to talk about something related, and that is the topic of ratio and proportion. Percent, if you remember, is just comparing a number to 100, so we have to write that fraction that way. Now we're going to kind of broaden that a little bit. We're going to talk about the bigger picture, and that's the topic of ratios, okay? Let's say you have 2 pens and 5 pencils. So in your hand here you have 2 pens, your hand here you have 5 pencils. So the question is, what is the ratio, and I'll tell you what that means in a minute, of pens to pencils, okay? So let's figure that out, okay? You have 2 pens and 5 pencils, okay? In your hands here, okay? What is the ratio of pens to pencils? Well, the way you write this down, and I know you don't quite understand this just yet, we'll get there. You say you have 2 colon 5, okay? What this means is this is the number of pens, and this is the number of pencils. So it's really nothing special. You just put the symbol in the middle, it's a colon, okay? And then basically all it means is this many pens corresponding to this many pencils, okay? That's all it means, okay? Now you can also write it as a fraction, and that's really the much more common way to do it, okay? You can write it as a fraction. Because you have 2 numbers here, you could have a 2 on the top and a 5 on the bottom. And this number is the pens, and this number corresponds to the pencils. What it means, okay, what it means is that for every 5 pencils, okay, that I find in a drawer, let's say, I think that I should find 2 pens, okay? That's what a ratio means, okay? For every 5 pencils, I should find 2 pens, okay? If I were to pull 10 pencils out of the drawer, okay, 10, not 5, but 10, so I would double this, okay? How many pens do you think you would find? Well, if I pull 5 pencils out and I expect to find 2 pens, then if I pull 10 pencils out, 10, then I think I probably should find 4 pens, okay? Because I'm doubling everything. I pull twice as many pencils out, so 10 pencils, okay? I should find twice as many pens. So what this is telling you here, this ratio is what we call it, is it's kind of telling you how many of something you have compared to how many of something else, okay? In this case, it's pens and pencils, okay? So any fraction that we've written up till now, remember we were multiplying, dividing, adding, subtracting fractions and all that. Any fraction is really a ratio. It's a top number compared to a bottom number. In this case, we're putting labels on it, pens and pencils. It could be cars and trucks. It could be apples and oranges. It could be any 2 things you're comparing, okay, when you have a big bucket of them, okay, and you want to find out how many oranges, if I pull 10 oranges out, how many apples do I expect to get out, that kind of thing. And so this is exactly what a ratio is. Now let's pick another ratio, okay, let's kind of get a couple more examples. Let's say you have, in a room, you'll say you have 2 women, okay, and 10 men. 2 women and 10 men, okay? What is the ratio of women to men? The ratio of women to men. Well, it's 2 women to 10 men. Just write it like this. 2 colon 10, okay? That means that there's 2 women for every 10 men, okay? For every 10 men, okay? Now you can also write this, as we said before, as a fraction. You can put the 2 and the 10 like this. So 2 women for every 10 men. Now, don't forget that this is a fraction, and you know you can simplify fractions, okay? And this is a ratio, but it's really kind of like a fraction. I mean, it is a fraction. You're just writing it with this funny symbol here instead of this funny symbol here, okay? But it's got the same numbers, okay? So you can simplify ratios like this and like this, just like you simplify fractions. That's the good news, okay? So if we were going to simplify this fraction, forgetting about the fact that it's just a ratio, how would we do it? We divide the top by 2 and we divide the bottom by 2, right? And we've been doing that over and over and over again. So the top would be 2 divided by 2 is 1, and the bottom would be 10 divided by 2 is 5, okay? And you can do the same thing here. You could do the same thing here, and if you were to do that, you would find that this ratio comes out to 1 colon 5, okay? You can do the same simplification here. 2 divided by 2 is 1, 10 divided by 2 is 5. Now in your books, when they give you something like there's 2 women and 10 men, what's the ratio? they're going to want to know the simplified ratio after you fully simplify everything and get it as simple as you can. What this means is that you had 2 women and 10 men. That is the ratio, 2 to 10. Okay? So for every 10 women, okay, for every 10 men, excuse me, that you have in a room, if you pull 10 people out, I expect to get 2 women, okay? But that is exactly the same thing as pulling 5 men out and expecting to get 1 woman. Okay, that's exactly the same thing. It's a proportion there. It's a ratio. It's proportional there, okay? Because if I take 5 women out, 5 men out, okay, then I expect to get 1 woman, okay? If I do that over and over and over again, and I do that, let's say, 2 times, then I would pull 10 men out, well then I would expect to get 2 women back. And then if I were to pull out, let's say 3 times 3, I can multiply this times 3. Let's say I would pull out 15 men out, and so that's multiplying this bottom number by 3. So I would pull out 15, 5 times 3 is 15 men out, then I would expect to get 3 women back, because this is the basic ratio right here. So everything's in terms of a fraction, okay? It's just expressing one thing compared to another, kind of like the percents, okay? Now we're going to do some problems to kind of show you why this is useful, okay? Because that's really the most important thing here, okay? Why is this useful? Let's say you have a bucket of apples in the grocery store, okay? You have 2 good apples picked for every 12 that you pull out of the bucket. So you pull 12 apples out of the bucket, and only 2 of them are good, okay? So you have a bucket of apples, okay? For every 12 apples picked, okay, only 2 are good. So that's not very good. That's a pretty ugly bucket of apples. 12 apples you pick out, only 2 of them are good. The rest of them are rotten, okay? So you have a ratio here. You have a ratio here. You pick 12 apples, only 2 of them are good. The ratio is going to be 2 good apples for every 12 bad apples, okay? You can also write it as 2 over 12, okay? Now, we can simplify these ratios just like we always can, okay? We can divide the top by 2 and the bottom by 2, okay? Just like any fraction, nothing special. 2 divided by 2 gives you 1. 12 divided by 2 gives you 6, okay? And so because this is the simplified version here, you can do the same thing over here. So this can be 1 colon 6. Just the same thing. 2 divided by 2 is 1. 12 divided by 2 is 6. So I was given some information. I was able to write a ratio of good to bad down. And so this is the basic thing. For every 6 apples I pull out, 1 of them should be good. And that is exactly the same thing as what I knew here. I just reduced the information that I knew, okay? Now, why is this useful, okay? Let's say, let's say your mother comes home and tells you that the ratio of good to bad apples is only 1 to 6. Then if I go back into the store and pick 30 apples at random, 30 apples I pick out of the bucket, how many apples will be good? So now I have a ratio, 1 to 6, good apples to bad, and then I go back to the store and I pick 30 apples and I take them home. How many good apples do I expect to have? Well, it's not that hard. You take the 30 apples that you're picking and you just multiply by your ratio, which is 1 good apple to 6 bad apples, okay? So to do this, I'm going to make it 30 over 1, okay, which is going to equal 30 times 1/6, okay? 30 times 1 gives me 30. 6 times 1 gives me 6. And then to simplify this, 30 divided by 6 is simply 5. So I should get 5 good apples out of 30. This is why ratios are useful. Somebody can go and do all the work for you and tell you the ratio of good to bad apples is 1 to 6. And then I could tell you, well, if I pick 30 apples, I'm only going to expect to get 5 good ones. And this makes sense because somebody goes out and does the work for you. 1 out of every 6 apples picked are good, okay? Here, 5 out of every 30 apples picked is good. So it's the same ratio, okay? It's the same ratio. So I could go and pick any number of apples. I could pick 250 apples and I could predict how many apples I would have good. And the only thing that I need to be able to do that is I need to know the ratio of good to bad apples, okay? Good to bad apples. This is why ratios are good. This is why ratios are useful. Okay? I'm going to do one more quick problem, kind of like a word problem, and that's going to be the following. You have a class of students. There's 20 students in the class. 2 out of 5 students have A's. And the question is, how many students have A's? Okay? So you have 20 students, okay? 20 students. And you know that 2 out of 5 have A's. Question is, how many students have A's? That's what I'm trying to figure out. You know that 2 out of 5 have A's, but how many students have A's total? Okay? Well, you have a ratio here. Okay? You have a ratio. 2:5, but really it's much more useful to write it as 2 over 5. You're almost always going to be dealing with the fraction. Okay? Sometimes you'll see them ask you to write it down like this, but this is really the much more useful way to write it down. Okay? So in order to find out the total number of students, you just take the total number of students, multiply by your ratio, which is 2/5. Okay? Now I'm going to make this 20 over 1 in order to multiply fractions, just like before. Okay? 20 times 2 is 40, and 1 times 5 is 5. Okay? Now to simplify this, 40 divided by 5, using multiplication tables, is 8. So 8 students have A's. Okay? So that kind of makes sense. Okay? 2 out of 5 people have A's. 20 total students in the class, 8 of them have A's. Okay? 8 of them have A's. And that's kind of how you do it. You define a ratio, which is what they're giving you here. Anytime you see something out of something, that's a ratio. It's a dead giveaway for a ratio. So when you're dealing with problems in ratios, look for the information in the problem that's going to give you the ratio. In this case, I gave you a 2 out of 5, so I wrote my ratio. Simplify the ratio if you can. In this case, you can't simplify it anymore, so we just stuck with it. And then if they're asking you to find the total number of students or something like this, you're just going to end up needing to multiply by that ratio. And multiplication is the way in which you use this ratio and you chop down that initial number to get what you're after. And that is an introduction to ratios and how to use them.